Hello everyone, and welcome to the Web3 Devs Underground. My name is Amit Chilo, and I am managing our wonderful community alongside our amazing team of volunteers and supporters. We're honored to welcome you all with us today. Before we dive in with our amazing guests, I would like to briefly introduce you to our community. We are a community of Web3, we are the Web3 Devs Underground. We're a community of developers and builders founded on open source values by Shauli Redjwan and Roy Osherov. Since our inception 4 years ago, we have consistently hosted in-person and online events, bringing together some of the brightest technical minds in the space. We are committed to delivering top-tier technical content to the global Web3 community. We're thrilled to have you all with us today. To stay in the loop for future events and updates, please join our main group on Telegram. All the important stuff is usually happening there. And I encourage you to follow and subscribe to all our platforms. We're active on Luma, meetup.com, X, YouTube, and LinkedIn. You can find everything on our website at web3devs.org or by scanning the QR on the top of the screen. A special thanks to our community sponsor, Masterkey VC, an early-stage venture capital firm specializing in infrastructure and deep tech across the Web3 ecosystem, with a team of 16 world-class cryptographers and several technical experts, led by our managing partner, Shauli Redjwan. Masterkey operates across all major crypto hubs. And now, without further ado, I am happy to kickstart our meetup. Today, we'll dive into confidential transactions on Ethereum, learn about FHE, or Fully Homomorphic Encryption, and get a chance to save our Bitcoins by learning about time lock recovery for Bitcoin. And let's start with a short introductions with today's speakers. So, hey guys, can you hear me?
Hi.
Hey.
Awesome. So I would like to start with a short introduction for the audience. Oren, why don't you start by presenting yourself?
Okay, my name is Oren. I'm a software developer for the last 20 years. I work on some open source projects like ln2.email and niot.space. And I also wrote BIP 128, Bitcoin improvement proposals, which is related to time lock recoveries. And I'm the founder of RightTrack, the company that implemented the time lock recovery solution, the monitoring and backup solution for pre-signed transactions.
Thank you, Oren. I'll also add that Oren is the past speaker at our community and an esteemed figure in the Israeli blockchain scene. So thank you for joining us today, Oren.
Thank you very much.
We will wait patiently for your talk right after Aurora. And Aurora, the stage is yours. Would love to hear a little bit about you.
Hey, nice to meet you guys. First of all, sorry for the weird location. I'm actually on my vacation, so I don't know if you can see outside.
Wow.
But
Go,
yeah,
Aurora.
I'm outside because there's bad new internet. So if the connection will drop at any moment, I'm very sorry. I will try to compensate in some other ways. Anyways, so a little bit about myself. I am now director of developer experience at Zama. Before I was senior DevRel, and before I had my own little company. So what should I say? I really care about the end user and developer experience for people, and I really care about how things are presented. So I work at Zama currently, so we are dealing with a lot of complex concepts like FHE, and we want to make sure that when we present things, they're sufficiently abstracted away so anybody can take them, grab them, and it's open source and anybody can use them. So yeah, that's the idea. So let me go into my presentation, shall we? All right.
Yeah, awesome. Maybe just to give a little bit of context to the people here not familiar with Zama. So Zama is the leading cryptography company building on FHE, which stands for Fully Homomorphic Encryption. If you can short, like brief on, like to get us to understand what's even FHE or what is this world that we're diving into. And yeah, we can dive into the presentation. And feel free to share your screen. Also,
I can go. Sorry. Yeah. I can go more deep dive in the presentation. Let me just share my screen. So,
okay.
share my screen.
By the way, I'll stay here with you and try to ask questions during the presentation. And
Nice.
everyone from home, feel free also to ask us in the comments anything that you would like us to explain again or dive deeper into. Yeah, let's start. Aurora, the stage is yours.
Can you see my screen?
Yes, you can see it.
The yellow, yes. Nice. Okay, so hello guys. I'm gonna present to you confidential transactions on Ethereum or EVM. Ethereum for simplification, EVM for if you know what that means. My name is Aurora Poppyseed. I have so I mentioned already who I am. I've been in blockchain since 2022. I meet at when I think it was FCC, no?
It was in Brussels.
Yes. It was super fun. So, anyways, it was super fun to be in there. And yeah, let's dive into what are we going to talk about. So first, it's gonna be like we're gonna put ourselves in the shoes of architects. First, we're gonna see like, okay, why blockchain kind of fails at confidentiality. So why we don't have privacy inside blockchains. Why is this not possible? Then we're gonna see like, okay, how are we gonna become like these kind of architects who are gonna plan our nice blockchain together, which actually includes privacy there. And then we're gonna kind of see what can happen now with as a result of that, and we're gonna like get into like what kind of tooling we have and so on, and how can you deploy maybe some confidential tokens. All right, so let's get started. So first off, blockchain fails at confidentiality. I want to first convince you of that, but let's look at what confidentiality is, because a lot of times these terms are kind of, people mix and match them and switch them. We have confidentiality on one hand, so that's obligation of those who manage information, and then privacy on the other hand, that's like more rights of individuals. So when you're talking about privacy, it's more like specific, like it's my right for something. And then when we talk about confidentiality, we're talking more about, it's an obligation of the bank to keep your information private. It's an obligation of the lawyer to keep the things that you talk to him about confidential and so on, right? It's very important to understand this kind of concept, because it's when you're stepping in the space of privacy, you're a lot of times kind of dealing with regulations, and then you're like, oh, no, we are not private, we're confidential. So this is kind of, how you want to frame it, right? So you need confidentiality. Anyways, let's go back to our question. So all of our data on our blockchain is actually exposed. When you see a bunch of transactions and you see, okay, you have a bunch of ENS names. Oh, it's pretty good, right? Well, no, actually, once you use one Ethereum address multiple times, we exactly know who you are, and you KYC yourself and so on. So we know who you are and who to target. So a bad actor can target somebody. Anyways, this is basically what our end goal should look like. Data shouldn't be leaked, and we shouldn't know who is who, right? All right, so kind of when we do the KYC, our data is actually exposed, and when we used like addresses multiple times, sooner or later we know who somebody is. So everything is actually public. All right, so now that we kind of understood that, how can we actually solve on-chain confidentiality? How can we put privacy on-chain? Well, okay, so this is kind of what we want to achieve. We have Alice here who wants to send 10K to Bob. And, this is quite, interesting, I mean, everybody would be targeting Alice because, you know, she has a lot of money, and they would see that she's sending this 10K to Bob now. So this is kind of what is happening behind what the end goal, what we want to achieve. So we want to make this 10K kind of private. So once we are doing, okay, if we put ourselves into the architect shoes, right? If we want to make this 10K private, we also need to make this balance private and this balance private. If we make this balance private, it's enough to use a private key of Alice. And if we want to make this 1.2K private, it's enough to use the private key of Bob. But as soon as we send the information of this 10K, we need some sort of universal key, because what is happening behind the scenes, Alice's balance is being deducted and Bob's balance is being, you know, so we need something to Bob to be able to decrypt, you know. He needs to decrypt those 10K. So we need actually a universal key. So a universal key that unlocks all chests, basically. Okay, so we are sending this money and we actually need a key. And this is how it looks like. When we lock, we actually send this 10K, we lock it, and actual output is kind of, we call it a ciphertext. So this is basically this kind of locked information. So where can we actually store this universal key? So we know we need to have it, but where are we going to put it, right? So we said, okay, blockchains are inherently public, so nothing is actually saved there, right? So, okay, it cannot be on a specific node, because if it's on one node, it's on all of the nodes, because nodes are duplicating between each other. So it cannot be on the blockchain at all, right? Maybe it can be on a server. So we put the private key on this server, and then it's being connected to the blockchain. Okay, that could work. However, well, I mean, it's a good solution, but it's not good enough, right? And that actor could target this specific server and could target it, and, you know, it could steal the key. We could say, oh, maybe we can put it in a, you know, TE or something like that. Well, this would be some sort of, you know, execution environment. Sure, that would work. But also then, you know, it would be one single instance. Probably still you could target it, you know, manufacturer would know what's the answer. The people who are doing it would know what's the answer. Still, you could figure it out. It's harder to target, but you still would know how to do it, right? Then, okay, so let's look at how basically we solve this problem. Well, we actually can split the key. So looking if we have any questions here, they're all good. Anyways, how we split the key. So we have one key, and then basically we say, okay, MPC, if you have heard of it. So you basically use 9 out of 13 signers to sign a specific thing. So kind of imagine you have, you know, the Thor's hammer, and then you have like, you know, you have to get all the diamonds together. And then when all the diamonds are together, then you can have the final Thor's hammer. no, not Thor's hammer, but the, you know, that, yeah, anyways, bad reference. So, okay, can we, yeah. So this would be kind of the multi-party computation. You have servers. This is kind of, yeah, servers, quotation marks, behind the scenes working, and together they produce a signature, and this signature is the whole universal key. But they cannot, you know, they cannot sign anything together. They cannot get the universal key. Each one of themselves cannot get it, and also if they collaborate together, they cannot get it. But if they collaborate together, they can actually sign something. So, okay, cool. We have kind of the answer, right? Okay, we are storing the private key. Amazing. But now we actually need to change an encrypted balance. And how we are going to do that? Because, okay, so what is happening actually behind the scenes? We told, okay, Alice is sending 10K to Bob. Actually, on the blockchain, what is happening is 10K is being deducted from Alice's account, and 10K is being added to Bob's account. All right. So we don't know what's Bobby's balance and what's Alice's balance. Actually, we can really nicely use fully homomorphic encryption here that allows us to do actually computations on encrypted data. Super cool. What is actually fully homomorphic encryption? This annoying long word that doesn't make much sense. So FHE has multiple keys. So here is actually a mistake. This is a secret key. Okay. So on FHE, we have a public key, we have a secret key to be different between the private key, and an evaluation key. So it's a similar analogy as you're used to from, you know, the normal blockchain world, where you have a public key that can encrypt all, that can basically, encrypt information. You have the private key that can decrypt information and you store it. But in this instance, this secret key would be this universal key that we were talking about before, right? So this would be this key. We would use it to decrypt information. And then we would have another evaluation key. As you know, from the normal blockchain world, you have a public key and a private key. The public key is derived from the private key. And actually here also the evaluation and the public key are derived from the secret key. So you have the evaluation key here. And actually this allows us to do computation on encrypted data. So what we've seen here before, Alice's balance is deducted. So this would actually happen there. So how it would look like in the, you know, in real life, or I mean, in practice. So 50K would be a ciphertext, 2K would be another ciphertext, and this one would be actually, when this would happen, and this would happen, this would be two homomorphic, fully homomorphic encryptions. So computation that would be happening. So you would have this and minus this would equal this, right? So it would be FHE dot sub equals, and then you would have another ciphertext basically. This is kind of our architecture. We can go a bit more deeper into it later. So this is how you would kind of construct it, because now, okay, now we got everything rolling, right? So we said, okay, we need to put MPC somewhere. Cool. So we have basically this MPC's key management storage. So we said multi-party computation, great. So the key management storage kind of takes care of this, but key management storage does a bit more than just MPC. So this is this block. Then these blocks are kind of, these two blocks are more for transmitting information. Let's simplify it. This is our EVM chain, it can be any chain. This is our user. So our user, when basically you would kind of transmit a sort of, so you go here, you say, oh, subtract this from this. Oh, cool. Okay, so this would pick up an event. The coprocessor would pick up an event. It would use the evaluation key that we managed before, and it would perform this sort of computation. These components are all actually living off-chain. So what is on-chain are only sort of, we call them handles, but they're actually, this is kind of our terminology, but but they're actually kind of pointers. So everything that you have on-chain, nothing is actually really, how you would say, nothing is, you won't see any ciphertext, because ciphertexts are quite long, right? So what you have on chain basically is just pointers. Like you can think of the normal computer science terminology. It would be just sort of kind of addresses to like some memory, right? And so this would be addresses. This would have the addresses. And so this would be an async process that would happen. So the coprocessor would pick up an event that would happen on chain, and then the computations will happen here. The multiple coprocessor, so it's sufficiently decentralized, and then these are passing information. So we said the evaluation key is kind of here living, then we have the secret key that is here. Every time we want to decrypt something, we actually go this sort of route. So we pass it to the relayer, and then gateway, and then KMS. So we can go a bit more deeper into it, but hopefully everything is kind of sort of starting to make sense. So what we actually created with, now going back to Zama, we put all this architecture together. So we try to make FHE-VM a reality. So this is FHE living on EVM. So we kind of try to make this architecture work. And by doing this, you're using Solidity. So you're using a bunch of new encrypted types. So these are kind of EUINT8, EUINT16, so on, to that you can use. And okay, and then now you say, okay, what can I use this for? Well, you can use it for private transfers. You can use it for confidential voting, blind auctions, encrypted DIDs. Mainly the best feature for using FHE. So FHE is kind of computationally quite heavy, that you have to kind of know. But when you are, doing the balances, transfer of balances, you kind of have really nice, well, it's a really nice sort of use case that you can have it. And finally, we can have actually private transfers. And also one of the cool features, so we partnered with OpenZeppelin. You have this OpenZeppelin confidential contract to make the ERC7984 confidential token. So what this is, like this is the standard way of making ERC20 token. So you would import ERC20 from OpenZeppelin, blah, blah, blah. You would create the constructor, initial supply, blah, blah, blah. Very simple, from the basics. Now, for the ERC7984 token, you would similarly go, okay, import FHE from FHE VM Zama, blah, blah, blah. So this is the FHE VM library, FHE library that Zama provides, but it's actually kind of a standard. This is a ERC7984 is actually a standard partnered with multiple people. Now, here we have, you might seem like, okay, what is this? So you have here Zama Ethereum config, but likewise, we are partnering, there are other people who actually can implement it. I think Inco has one implementation. So you could have here Inco Ethereum config, or you could have your own implementation or something like that, right? So this is implementation on Ethereum. Then you would have a constructor, ERC7984 standard, and then you would mint with the initial supply, similar as you did before. So this would kind of how the output would look like. In the standard way, what we've seen here, you say, hey, Alice, what is your balance? Oh, my balance is 20 ETH. So you would get some output like this. In this ERC7984 token, the balance would look like this, right? So confidential balance of Alice, everybody would see just a simple, this would be kind of handle. It's actually it's pointer pointing to a ciphertext off chain. And then only Alice could decrypt it. And it would give you, 20 ETH or 20 wrapped ETH in a confidential way. So let's look at some of the resources. So these are OpenZeppelin confidential contracts. You can actually go on the docs.zama.org to check out how you can start with some of the resources. So this would kind of be it of the my presentation. Now, I guess let's address any questions you might have, and then we can do a little bit of coding maybe. Amit, do you have any questions?
I would love the coding review. And just to start, maybe to try and simplify it so that I make sure to understand. So first of all, FHE is a privacy technology, right? What are some competing privacy technologies, and what the differentiators? Maybe like I'm familiar with zero knowledge, and MPC, but like if you can expand on that a little bit and what make FHE special.
So FHE is basically, okay, you put a lot of terms here. This is a lot of time confusion people have. So ZK is basically a zero knowledge proof. So you kind of can use both together, ZK and FHE. So ZK proof would look like you have something off chain and you want to prove that this is correct. The nice illustration is but I'm probably not the right person to explain this, but the nice illustration is proof where is Wally, right? Where is Wallow or Wally, or I don't know how it's called, Walla, without exposing the picture, right? So you have this picture and then you basically cover everything up and you say, here is Wallow, but you won't see it, and then I uncover it and you see the picture, but you cannot find him, right? So this is kind of, you you do basically a proof that you're doing this. If you want to do confidential transactions, so I could make a proof proving that I have this amount of money off chain somewhere. This could always work, but you would need to trust some sort of server where it's holding my information. So it's not, for this kind of use case, it maybe doesn't make the most amount of sense, right? For this specific use case of, of confidential transactions. Confidential transaction doesn't make that much sense. But maybe some cryptographer somewhere will say, "Oh, what are you talking about?" Right? So it's a really nice pairing. For example, we cannot do. When I said before, what are use cases? So I said confidential voting. I said so private transfers. That's the biggest one. So for the what do we have here before? So private transfers with kind of with traditional banking and so on. That's the main kind of use case. Well, not traditional banking, but any sort of Web3 banking, right? That's the kind of the main use case. Other use cases are like confidential voting, we said. Then I encrypted DIDs. So a nice example is in encrypted DIDs, you don't have that much, when you do FHE, it doesn't make that much sense because you have potentially, you have, let's say, how you would do DIDs. You have a passport somewhere, right? You would need to store it off chain. It doesn't make any sense why you would store the whole entire passport with all your data, even if it's encrypted on chain, because it's too much information, right? Anytime you have too much information, it doesn't make sense. So what you would do is you would do a ZK proof that you have the passport somewhere off chain. Then you could put it on chain. So then you could do this proof on chain. And then, so on chain, you would have only the proof, not the passport. But you could have also store some sort of where Zama could come along, so where FHE could come along, would be, let's say you would want to prove that you are over, I don't know, 21 years old, that you could drink, or that you are over 18 years old, that you could, or that you are actually under 18 years old. Maybe you want to have multiple like different specifics. Like for example, you don't want some pedophiles, some sort of, I'm giving you like examples, right? You don't want some, and you want to have a proof for that, or like you have multiple things that you want to do computations with, right? Like multiple different markers. Then it would make sense for this information to be on chain. But it would have to be like some smaller, like age. Let's say you would have, like not big data, that kind of the story where I'm going it with. And then MPC, we are using MPC in a sort of our context. The MPC, as I mentioned before, it gives you the ability to store this private key somewhere. So you're doing this. Somebody told me that MPC is just sophisticated multisig. So basically, you are kind of storing this information somewhere, and you're storing this in universal secret key somewhere, so you can basically use it to unlock information. But well, you cannot do computations on encrypted data, so you would need to, every time you would need to compute something, you would need to decrypt it, right? Imagine I would be transferring you money, I would need to decrypt my money and then transfer you, and then do the computation. Or let's say I would be, before when we had example, okay, I'm Alice, I'm giving you 10K. I would need to do this. I would need to decrypt how much money I have, and then do the computation, and then encrypt it again. It wouldn't make much sense, right? So this is kind of the ways how you could do it. You could also have like TEs. This is another private solution that we failed to mention. So TEs is actually behind the scenes multi-party computation. Each one of the nodes is actually a TE. Each one of the holders of the secret key is actually a TE. So you can have, this is kind of our example of a server before. It's okay.
Can you explain in a few words what's a TE?
Yeah, so TE is a trusted execution environment. So I'm not an expert to explain these kind of things, but yeah, TE is a trusted execution environment. So you would have, for example, some sort of it's a
hardware device, right?
It's for example, a ledger would be trusted execution environment. So okay. And it has some limitations on how much things you can compute and so on. But it's not that secure, right? Because you have just one. Imagine you would have, if you have the entire privacy protocol reliant on one TE, if that TE gets compromised, well, your privacy goes to shit, right? Yeah. So that's kind of the idea. And then people are doing all sorts of different stuff with the TEs. You can send them to space and so on. But those are all varying. So how I would say this privacy a lot of times are like, what are the privacy assumptions that you want to do? So in Zama, we try to minimize privacy assumptions. What does that mean? To make it, to assume nobody would have control over anything, right? So to assume that no parties can, expose this information if they would be targeted, or if they get compromised or something like that, or if they collude together. So least privacy assumptions, but most sort of decentralization. So that kind of, when you combine those two together, you kind of have to have a more complicated architecture that emerges out of it. So then you try to have even faster execution, and then you're like, okay, these are quite a lot of different criteria that I have to abide by. So yeah.
Okay, so do you want to start with the code showcase, or would you like to start with the Q&A? I would like to add also Oren and Eden to help me with some questions, and maybe ask some questions from the audience. But whatever you like to.
I can start with the Q&A, Actually, there's two options I can go to. I can go to showcase more code. Depending on the audience, what would the audience more like? If you guys are more cryptographers and would like to see that, we can go more in depth into the architecture. Those are like kind of a lot of times the requests, or we can go more into the code. So yeah, just maybe let's answer
Awesome.
some questions.
I would love to go a bit into the cryptography and code if you'd like, and we have a lot of questions ready for you. So
Nice.
we can ask all the questions after that. And hey, Eden, great to see you as well. So yeah, feel free if you do you want to share a screen again, Aurora?
So should I go more into the code part or more into the deeper dive into the architecture?
I would like to see some code, but whatever you prefer. If you have both ready, you can go go into both.
Let's go. All right. Can you see my screen?
Okay. Yes. I think so.
Okay, nice. All right. By the way, my my fingers are freezing. Super fun.
It's good that you will move your hands a little bit.
Yeah. Actually, it's Web3 Devs the underground, but I'm not gonna type too much. It's like, Anyways, let's get started. So, what I would recommend you to actually get started is with this FHEVM React template. This is a nice one. Or you can actually go also, this is a nice example as well. Maybe let's go this. It's more fuller.
Yeah, just to help people that want to start with FHE, we would appreciate if you can share all the links and everything. We'll share them in our Telegram group.
Yeah, for sure. So these are kind of our example templates.
Can you make it a little bit bigger? It's a bit too small.
Oh yeah, sorry. Here you go.
Yeah, much better.
So this is gonna maybe take us a long time to do, but essentially you go either here are more like in-depth, basically more like concrete examples that you can do. This is more like the fresh template that's trying to reduce it as much as possible. Anyways, this is, you have here the packages. So one of the packages is the base hardhat template that you can actually see. And when we go to the contract, you can see how it actually looks like. So this was the example that we saw from before. So this is the FHE. Then you have the Zama Ethereum config, right?
Mm-hmm.
So you are creating a counter. So you have you define a private count with the encrypted types that we defined before. So this is the encrypted count. So it's, when you see this, is basically an encrypted uint. So we can check it how it looks like afterward. Anyways, but so if you want to kind of increment or decrement, you will do, so you will basically be encrypting this information off chain. So you will use the public key. So what we were talking about, if you remember, there was the FHE, public key, secret key, and evaluation key. So you take the public key and encrypt the information somewhere off chain, and then you will call, basically those will kind of give you the handles. So this is kind of this pointer that we were talking about. So it will make sure that the information is in the right format, it will give also an input proof. So this is basically a ZK POC proving that you are the sender. And then you will do from external. So this will be basically verifying the ZK proof. And then also, so this is basically a user kind of ZK proof, so that you are actually the user. So this kind of information basically will be put in the correct type. And then you would have basically add to the count that we defined before, the private count. And you would add this sort of encrypted EUINT32. And then, of course, after every transaction, you never assume that one of the concepts, actually there are two concepts you need to know when you are dealing with, so you need to know how to program in Solidity, that's one thing. But when you are doing things with FHE, you actually you always have to specify who has the permission to view some value. We call this the ACL, so access control list. So here we say that for that this contract, so allow this is an abbreviation, that this contract has the permission to see this count value, and that the message center has the permission to see this count value. Another concept is also how you do if then else sentences. You cannot do if else. You cannot do if else, because if you think about it, so you cannot do, oh, if value is 0, return, because all values are actually encrypted, right? So you can never know when a value is true or false, right? So you cannot do if and else. So you have to kind of take the values that you defined from the start to the end. So I'm going to show you an example later on. But yeah, okay, so we got the dApps cloned. So cursor. So I'm doing a pnpm install here. It's going to install all the different packages. Now I'm going to do a pnpm test. This is going to have like multiple different examples that we've seen before. One of the cool examples is the ERC7984. So no, this is not it. This is the hard hat. And here we have the contracts. Do you see actually my screen? Maybe like this?
Yes, it's a bit small, but I can see it.
Yeah, it's hard for me like this, but then I have trouble to show you anything. So here is the Open Zeppelin confidential contract. So to get started, if you want to get started completely from scratch, you would have do this. You would use the hard hat template from the FHEVM, clone this, and then also add the Open Zeppelin confidential contract as a npm package. npm install Open Zeppelin confidential contract. You install this, and then you can use it in this sort of way. Import ERC7984 from blah, blah, blah. Okay. So here is one of the examples. So you have the Zama Ethereum config. And the ERC7984 from the Open Zeppelin confidential contract. There's a bunch of text here, but we can see, okay, you have an amount, you have a token, you have a name symbol, very similar as before. Then we have two similar functions. Okay, so this is a clear mint. What does clear mint mean? Is that basically everybody, if you're adding a value, anybody can see it. And then we can go actually into the definition of the ERC 7984. There's a bunch of stuff here, but so you can see everything is actually kind of confidential. You have the confidential token supply. And actually what update does here is to see, for the owner to see every time the something changes, we allow the owner to see what is the actual confidential token supply, total supply. But this is less privacy assumption. So you can have it without minimal privacy assumptions. It would look like just plainly like this. This would basically have minimal privacy assumptions, right? Anyways, so this is the, okay, so confidential transfer from is, yeah, so we have this transfer function, transfer. Yes. They changed a few things, so I'm not sure where the part is that I'm trying to show you. Maybe this is not the best example because it's not the easiest example to get started with. But see, the patterns are quite similar, right? So when you have a confidential transfer, you are doing, you are basically doing this external EUINT 64, which means that you are encrypting it somewhere else. You're doing the input proof and basically calling it. So if we check how this looks like, yeah, so it's basically the transfer. No, yeah, okay, so yeah, okay, so the update function is the main function. As you can see,
that actually changes the like
sorry?
the balance. The update function is the one that changes the balances.
Yeah, exactly, yeah. So this is not the most the easiest example to show you, but maybe like you see a bit what's going on under the hood. So you see you are kind of dragging all the time the amount later on, right? So you see like what is transferred. So you see like, okay, if it was successful, the amount was transferred. If the successful wasn't successful, then the amount wasn't transferred. Something like this, right?
Mm-hmm.
So you're dragging this later on. You cannot do require, or require success, and if success is 0, then you just return it. You cannot do this in FHE, right? You're dragging these encrypted values all the way down to the bottom, right? That's the only
Is this
kind
one of the reasons that it's so heavy?
No. The main reason that it's heavy is just because of the inherent properties of fully homomorphic encryption. So I'm not I'm not a expert in that, but you have so beyond I cannot tell you much, although I think if you Google yourself like the fully homomorphic encryption, there is maybe fhe.org will have something more. No. Yeah, let's see. Kind of, you have to know that anytime you do a computation on the fully homomorphic encryption, it gets more messy and messy. So you need to do sort of this kind of cleaning. There's a cleaning function, but I forgot the exact terms. So because it's so far away that I was talking about this that that I forgot the correct terms. Anyways, closing that. Okay. So kind of this is how you would do it, right? So as you can see here, you have this FHE select. So FHE select basically means it's an if then else kind of statement, right? If success is true, use this. If success is false, then use this, right? So you would use just a simple 0. If success is true, then, well, then do the amount.
And then I guess the zeros are not encrypted or anything.
So the 0 is encrypted. However, in this instance, you are correct. This is not an encrypted value. So this is just, when you are using it in this sort of way, you are using FHE as EUIN64. You are kind of taking the 0 and you are putting it into the handle format that the fully homomorphic encryption behind the scenes can understand, that the FHE VM can understand when it's doing the computations. So this is just a trivial encrypt. What a trivial encrypt means, that no actual encryption is going on. So it's super easy to understand when you construct this handle that this is actually a 0. Differs than this amount, where we were specifying it kind of here, but even more before we were. So yeah, okay, so this already uses the EUINT, but here we are kind of constructing, even more before, okay, even before, yeah, here. So here we were constructing it, right? So this is the function that you would call off-chain, and basically you would use this, you would create an encryption off-chain. Okay, so let's see what we can do now. Okay, so as you can see, all the tests pass. Now we can maybe do okay, so we can do like this. We can run a chain. We can deploy localhost. So now I'm deploying localhost and do run tabs. Oh, sorry, run start. Okay. Probably it will tell me blah, blah, blah. You didn't specify this and that. Let's see. Seems there are like some sort of issues. Okay. Can I run already example that I already created? I'm cheating a bit now.
No problem. And I think we would like to also ask few questions and let Eden and Oren join us as well. So let me know if there is anything you would like to wrap up about this example, or would you like us to dive into the Q&A already? I see we have a lot of questions from the audience already.
Sure. We can dive into the Q&A.
Okay, awesome. So first of all, I would like to also present Eden. Eden is also a co-manager in Web3 Devs Underground, and we have Oren here that you already met. So guys, feel free to just jump in, ask anything you would like to ask. And just a sec. Okay. It's all here.
So I wanted to ask a question. So when two parties transact with each other, the details of the transactions are all encrypted. and only they can see the details of the transaction. And even they cannot see in each other's account, but they can see that calculate that the exchange has been done and the funds were there and were increased. But can other people see that those two parties have interacted with each other? So you can still create, by following the blockchain, you can still map who make transactions with who. Not the amounts, but
Yes,
does
correct.
it encrypt also that data?
Yes, we can see everything actually. We can see. We can see. So what would happen on the end? At the end, you would basically be seeing that a confidential transaction happened, but the handles would be encrypted. So the value where usually you would see kind of the money transferred, right? So you'd see like 20 ETH, you would see basically a hash there.
Yeah, but the accounts themselves are not hashed. You can still see that Alice did a transaction with Bob.
Yes, correct. Yeah, you can see everybody, who is who. You just don't know how much money they have.
Yeah.
That's what I mentioned, like on the start of my talk. I said distinguish between confidentiality and privacy. So true privacy is basically everybody, nobody knows who is who. Confidentiality is like, okay, you can know who is who, but you don't know how much money we have. So it's like, okay, you know that I went to the lawyer, but you don't know what I discussed there.
Yeah.
Well, I don't know. Hopefully I will never suing you, but let's see. No, kidding. Yeah.
Awesome. Eden, do you want to ask a question as well? I have some as well, so I'll wait after you.
I have a few questions of my own, but I want to first ask a most recent question from the audience, actually. So one moment, I'll share it on the screen.
Okay, so I'll read it aloud. Mine. Yeah, Eden, you go.
Okay, so Arm is this ask if I have an encrypting value and another encrypted value, I can operate this to keeping them encrypted, correct?
Correct. Yeah. Correct. You can
you
subtract
do more
these
than
two
two, by the way?
values. You can multiply them. You can do. I can show you maybe like all the different operations that you can do.
Yeah, that would be awesome.
Yeah, or maybe I can just paste it. Yeah, nice.
Also good.
Can I paste this in the chat directly? Okay. Ultimate laziness. Sorry, my connection is really bad.
No worries, I'll put it in the comments and in the Telegram group. Okay, awesome. Next question. So Eden, you go. I'll be after you with my questions as well.
One moment. Okay, a question is, can I do a token transfer with an encrypted value?
Yes. Yes.
All right. Any token?
We have. So you can basically. You would need to wrap them in a confidential manner. You can actually check. I'm not sure if we already. Confidential wrapper. Gonna send this in the chat as well. Okay, so basically you can wrap any sort of USDC, USDT token, Ethereum token to make it, or the wrapped Ethereum token or something like that. You can wrap it Basically, yeah, okay. You can wrap also the Ethereum token, but it's a different contract. Or you can make it your own. You can use the library that I shared, the Open Zeppelin confidential contracts.
Mm-hmm.
No. So this is one of the resources. You can share this into basically, you can use this open standard for creating a wrap token. And then once you create it, then you can basically transfer confidential values with it.
All right, that's awesome. Amit, you can go ahead while I open my questions.
Yeah, sure. So he has another question, Armes. Continuing on his last questions, if it's an ERC 7984, can he operate to make a transfer with an encrypted value? Yes, an encrypted value.
Nice. This is the same person. Maybe we should ask him to to the stage. Once again, this is if it's. Can you read it again? Sorry.
Yeah,
if
sure.
it's an ERC 984, can I operate it to make a transfer with an encrypted value? Following my previous question. Correct. Yeah, you can make a transfer with an encrypted value. That's how you make a transfer, with an encrypted value.
Okay. The next question from the audience is, what is the maximum value as amount that the encrypted ERC20 can represent? So there is a type of ATUINT.
What is the maximum values of as amount that can represent ERC20 represent? You mean the decimals? Like how many decimals it can have?
I guess that's what they mean.
I guess what they mean. So if we say, what's the normal value that ERC20 can have? I'm gonna ask Perplexity.
But is it not limited to like it's
limited,
what's the
yeah.
limitation on Ethereum
It's
is,
limited,
right?
yeah. It is limited because you want to limit amount of, actually we do limit it. So commonly 18, but can be also 6, 8, 0 and so on. So I think our tokens are actually limited to 6, but I would have 2 or 8 decimals, something like that. I'll have to check because maybe they changed something now. And actually I can also give you something else.
By the way, there is a refreshment of the questions. He asked, he meant what's the balance field in the mapping? What's the maximum number?
Oh. You ask me too much, honestly. But I would guess it's the same. Only I think the balance field is the same. I think what they changed is only like how many decimal points they can have. That's the only thing.
Okay.
What are the max?
Okay, I have I have questions. I have a couple questions from Nathan. So first one, is there any other threats for these than just hardware? And he has a follow-up question on it.
Is there any other threat for TEs than just the hardware? I don't understand.
I think he means like if you can like breach a TE in other ways than just like physically breach them.
Yeah.
So I'm not a security expert, so I have a hard time answering this question. I guess there would, I mean...
Okay. No.
So I know there is the kind of from my limited scope of knowledge on this topic, I know there is the manufacturer of the tea. I guess if somebody, well, I mean, if you have a single source of failure, actually, funny enough, last time, like my friend got his ledger hacked because they had a call with him and they told him to do an update on his ledger, and then they were like kind of pushing him like a lot, and then he was like, oh my god, I have to do it, and then actually, they stole his key in that sort of way. So that's a little story for you.
Phishing is the main concern, I guess.
So max decimals would be 6.
Great. Okay, so one more question.
Is the encryption
Is
scheme
the encryption scheme making use of polynomials? And she has another follow-up question on it.
no idea.
Okay.
So
It's another security one for us.
No idea. You'd have
yeah,
to.
we might save some of those questions for one of the next.
I mean, if you want to go like underlying, like Zama basically started as a security kind of. There are a lot of employees in our company, so we started more like underlying like security, sorry, not security, but like privacy research, like fully homomorphic encryption on the Taurus. That was like the Pascal Pallier. He was working 10 years before Zama on that, writing papers and so on. So they took that, and then basically they created one of the first libraries that was created was TFHERS, which was the primitive Rust library that is Zama relying on. Like everything is our technology is relying on that. So if you want to see like how some sort of implementations are done, I would suggest looking in there, but I haven't done so myself, to be honest with you.
Okay, so I think we're done with the questions from the audience, at least for now. Eden, would you like to ask our questions?
Yes, of course. Okay, so first question is data consistency related. So when dealing with distributed systems, highly scale, how do you handle the data consistency? In your production environment, is there a constant trade-off between speed and finality?
So are you asking me what is the speed of finality in the, well,
not per se what's the speed of finality, but like
data
more
consistency. So
yeah,
you have to know. Okay, so when people ask me questions about FHEVM, they make a lot of times analogies on FHEVM being similar to L2s in the architecture. So it's kind of a completely different architecture. It's an FHEVM architecture where basically you have handles on chain, which are like pointers, and then you have all the everything, all the stuff is off chain. So all the ciphertext, all the, well, even clear values, all the computations, everything is done off chain. It's done in different sort of ways. So you have like multiple coprocessors, we have which are kind of sufficiently decentralized. They're like running sort of, kind of node environments. So those are one specific type of thing. So those are kind of, well, they're coprocessors, they're not nodes, right? So they're directly linked with the Ethereum or any other EVM, linked together. So here, actually, what is all the computation? But going back to your question, so how do you deal with data consistency. So you're just, I guess it would be similar to a sort of, if you would think about more a classical, not Web3 sort of system, but a computer system where you would have pointers to sort of memory blocks, right?
Yes.
This kind of pattern.
Mm.
So
right.
that's
So
the
it's like,
so it would be somewhere living off chain. And then other question was, I forgot the other question.
it was a follow-up question on it. I mean, I think I asked if there's a constant trade-off between speed and finality in that case, but I think if it's living off chain, maybe that's.
Yeah, so if it's basically when you're like saying, how do we make it faster? We are dealing with one of the major limitations. Well, there are few limitations, but one of the major limitations when we're talking about speed is the computation speed of FHE. And how you solve this is multiple, you can have one of the stuff is our cryptographers are constantly working on refining our algorithms and how to make FHE, the underlying FHE, faster. So there's ongoing research on that. But then you have, okay, where are the computations actually going to be run on? So you have CPU. So this is basically you can have a CPU. Then we are actually doing the research. Then I'm not sure. I think we have it now on CPUs. Then we're gonna have it on GPUs, and then actually there's doing also research on how to have it like on actual, like FPGAs. So in the FPGA environment, so it would be super fast, but then there's a substantial investment that would need to happen to make that a reality. So now this is just in a research phase. So that would be like cool. Do you remember like ASIC miners maybe? Those were run on FPGAs.
Mm-hmm.
That's what you refer to as FHE, like accelerators?
Yeah, well, I'm saying that the underlying limitation on the performance, on how fast, you say finality, or how fast basically the finality is the more Web3 world, like how fast the computation speed of FHE executes. Well, the major limitation behind the scenes is the speed of this fully homomorphic encryption. How long does it need to, from this to this, how it subtracts and so on. And then, or like if you say FHE dot sub, how long does this computation need, right? Because this is like an underlying cryptographic computation that needs to happen. So how to speed it up? Where first off, where are you running it, right? Currently, we're running it on a CPU. So you can say, okay, let's scale up the CPUs. Let's make it like multi-threaded and so on. That's already happening. Then you can say another stuff. Okay, let's run it on GPUs. That's going to happen. And then another thing is like, okay, let's now put it on. Do you remember like ASIC miners?
Can you give us a bit of context to those who are not familiar?
So you have, I don't know if you remember the era of when everybody was mining on their like GPUs, the Bitcoins and stuff like that.
Mm-hmm.
Not so long ago.
Not so long ago.
Yeah, exactly. I mean, not so long ago, a few years, right? So everybody was like doing the mining and but basically this on the GPUs, and then actually we knew like, oh damn, this is never gonna be so fast as the ASIC miners that that were being present at the time. One, basically, you have like hardware devices that are just configured for running that sort of transaction, right? So you have it's called FPGA. I don't know how to other like what would be a different sort of analogy, but you go very, very low level. You like basically program it in a very low level way. Then you have like this sort of chips, and it basically burns it by itself, and and then this is the only thing that it knows to do: compute A plus B. Okay, I'm gonna be the fastest in computing A plus B. Bam, right? Or I don't know. Be the fastest at computing Pythagorean algorithm, things like that, right? So you would construct a machine that would only know how to do that. So that was kind of the analogy, but maybe it got, So yeah. Any other
Okay.
Yeah.
Yeah. So regarding developer mistakes, for developers building solutions or integrations in your space, what are the most common architectural mistakes you see them making from day one? For instance, you mentioned the theoretical aspect of like looking at it like an L2, which is not. So any other maybe mistakes you think you've seen, you think some should avoid?
So there are not that many concepts that you need to know. We're gonna make it better and better with better developer abstractions. If you are already a good enough Solidity developer, when you are doing Solidity for some time, to minimize for loops and stuff like that, right? So this is one of the things that you have to know. And then two things that I showed you. You have to think about the ACL, which is quite basic. You have to define who can view the value. Anytime you do a computation, you have to allow for the contract itself to view the value in the first place. That's the first thing. The second thing, and second thing would be this if then else, right? You don't have, if this is happening, just throw error. You don't have this concept, so you kind of drag this. So if if the account does not have enough money, then to transfer, then we are still transferring, but we're transferring 0, and then go on and go on. This is one of the kind of the underlying principles. So to make it production ready code, right? Other than that, you just need to be good in Solidity. And then in the front end, well, on the front end, you're actually handling encryption and decryption. In the encryption and decryption flows. With the encryption, maybe you need to think about how you would store. Remember, so when you are doing actually decryption, there is actually a private key. Hopefully I won't lose my audience here. There is a private public key being generated that is specific for the user. So
yes,
it's not a same private public key that you see when you are constructing the wallet, but it's a different type of private public key. And this it's just so used so that the TFHE can basically pass you information forward from the from the underlying mechanism, from the relayer, passing it to you as the user, so only you can decrypt it with your private key. So it can use your public key, and then you can only decrypt it. That's the only kind of thing. And then where you exactly store this, we haven't, us in Zama, we haven't really figured this out. Maybe it would be nice to partner with some sort of like wallet providers and store it directly there, or depending on how
interesting.
how you would architecture the whole system, maybe it would be interesting to think about it. But it's the only thing is like, okay, if you're caching the signature, because every time you want to decrypt something, you need to sign it. If you are currently like, you can cache the signature itself, and then you don't need to sign it every time. However, if you cache this in storage, maybe somebody can do like an XSS attack and just be able to take this, and then he would be able to see your values, which would not be good for you, I guess, because it would defeat the point of privacy.
Yeah.
But then they could, you can set them. So it's up to the user how he would set it and so on. Maybe a little, like, you have to have a little bit more thought. But we're going to abstract it sufficiently so when the end users will kind of not have to think about it. The whole idea is like, okay, you won't have to think about it. Like, we will think about it for you. But
great
for
news
now,
for us.
you have to think about it. So yeah.
All right. My last question. So regarding our extreme hype of AI agents right now, 20 is going to be the AI agents year, apparently. Are there any plans for APIs allowing FHEVM smart contracts to directly call off-chain autonomous AI agents to operate exclusively on cheaper texts effectively?
That's a good question. Actually, I don't know. But this is like, can you write this down? I'm gonna get to our
Yes.
CEO. Like, we should do that.
Yeah,
So, yeah,
for sure. I'll share it with you. Well, I have a simpler question. Are there any thoughts or plans at all regarding AI agents, in your basic architectural solution?
I mean, so first off, like, everybody is, so people in our company are using AI agent daily and so on. This is one thing. Another thing is, maybe like in the next, one of the things that we're gonna have is, the if skills that the really cool, I don't know if you've seen it on the internet.
The skill, like
if skills, yeah.
the agentic
Just
skills?
the slash commands, if skills, blah, blah, blah. It's really cool.
Okay.
Anyways, or like you have also like skills for the audits, stuff like that, for auditing Solidity code. I think we're gonna bring something like that with FHE, so you can just do commands like slash
Great.
FHE VM or something like that, and then it will generate a Solidity contract for you, and you won't have to,
Yeah, because we know it's
Hopefully
it's
we'll
out
still
there
think
already
about
with Cloud Code. Yeah, because it's out there already with Cloud Code, auditing and performing security actions for like Web2 codes or whatever. So it would be awesome to see it also in FHEVMs.
Actually, I shared in the chat. I shared one of the stuff is like the Chat GPT. I mean, it's one of the. I don't have the skills yet, but you can see like this ChatGPT implementation is actually taught on our docs and so on, and you can like talk a little bit about it. And if you have any other like questions on our architecture and so on, you can check it out.
Awesome, thank you. Okay, so Amit, I'll pass it on to you.
I will not ask all my questions because we want to proceed to Oren soon. But I do have some questions for you, Aurora, as Aurora. Let me know if you can hear me because your picture disappeared.
Oh, I thought I'm finished. Okay. Nice.
Yeah, I have some few questions for you as Aurora. We would like to learn a little bit about you and your process in the ecosystem. So I'll start with like, what did you do before like joining the ecosystem? How did you initially get into this space, in this specific field of FHE? Yeah, maybe start with that.
Before the Zama ecosystem, I guess you're asking.
Yeah, and even before joining like Web3, like how
Before
did you get
joining
into
Web3,
Web3?
oh my god. Jesus. Okay, so before joining Web3, I was actually working. Well, first I was starting. I did some physics. Then I did actually electronics. Then actually I got hired by a company that was doing measurement devices for particle accelerators. Yeah, I was doing
That's
like
awesome.
really cool chips, like the 12-layer chips for particle accelerators. So you would put it on the end particle accelerator, and it would basically get the inputs inside, and it's really cool. It's really cool stuff. So yeah, I meet you. You're a physicist, so you know what I'm talking about.
I love it.
And
I see
then I
so
was
many
like,
physicists in the field. It's amazing.
and then I was like, okay, I mean, okay, this is cool, all and all, but I'm driving so much because every time you need to go, you need to be physically present, and it's not the best lifestyle you want to have for yourself. You know, you cannot do shit like I'm doing right now, right? um, so wait, maybe I can unblur my picture. I can show you my background. Oh no. I cannot show you. Why is it
Yeah,
blurred?
no worries.
I don't know. Anyways, maybe visual effect. None. Okay. Yes, now. Okay. Nice. Like, look at this beautiful view. Okay. Just gonna share
This
with
is
you.
not a requirement for next time, Oren. You can also do it
Yeah.
on a vacation.
Right
Yeah,
now
you
there
need
are
to
no
be in a
flights.
full location. By the way, my laptop is dying, so you guys know. Anyways. So yeah, the problem with hardware is super cool, but it's slow. Like the how it's proceeding is super slow, and then it's currently it's like computer error time, and hardware was quite more popular back in the days. So there's not much, you know, that much evolution happening in the hardware. Hopefully now with the AI, things will be going faster, but there's a lot of proprietary knowledge with hardware as well. So kind of nothing is much open source. If you have like good cool processes and so on, so it's like a slow process. You were like slowly moving in the company up and up. There are people who are 20 30 years working in the same company in the same industry, and and you're physically driving to the location, so you're tied to that. So then I was like, okay, let's go to crypto and let's go more to I was working at the same company, but I was more working on the web stuff, and I was basically going to different conferences and hackathons and so on.
Oren, do you wanted to add something?
And you are saying that now in the age of AI, there is no more proprietary knowledge and no more copyrights, and everybody are allowed to copy everything from anybody.
I didn't say that. You make some assumptions here. Yeah, of course. No proprietary knowledge. Like we know everything about you, Oren Zomer, where you live, where you are going.
No,
Yeah.
I'm saying copyrights and stuff like that. Now you
Yeah,
can say,
okay.
oh, oops, my agent copied it. It wasn't me.
So you'll have the robots being deployed at your home, which will be looking at every action you do. No kidding. Anyways, enough jokes. Okay, so yeah, that's enough about me. My computer is unfortunately dying, so if you have any other questions or so, and
So maybe one last question is before you have to go. If you have any tips or anything you would like to share with our community, that might be valuable, that you learned along the way.
Any tip, like life lessons.
Whatever you would like to share and you think is valuable for mostly for engineers, developers, builders.
Mostly
This is
for
our
engineers, developers. That's okay. So your life is limited and goes fast. Think about what you want to achieve and do it quickly. Stop procrastinating, I guess. Stop putting it off. So yeah, that's my advice.
Awesome, I'll take it. So thank you so much, Aurora.
Enjoy, guys.
I will continue to question you with more questions privately later.
Thank you for hosting.
I would like to thank you for joining us today. It was a pleasure, and we hope to host you again in the future. And yeah, let's give the stage to Oren for the next
Oren,
lecture.
good luck.
Thank you, Aurora.
Bye-bye.
If
you very much.
if you want on your vacation, you can stay with us and ask Oren some questions later.
I
and,
have
come back
to go to my kids, but good luck with your presentation and everything. Bye-bye. Enjoy,
Thank you so
guys.
much, Aurora.
So let's see. It's the first time I'm presenting on this platform. Amit, can you make my slides appear?
Yes. We're
Oh,
fine.
okay, great. So welcome everybody. This will be a much simpler talk than all the mathematical complications from the present last talk, because we are talking about Bitcoin, and Bitcoin is much simple. And we will be talking about recovery mechanisms and about how we can use time locks in them. So why do we need recovery mechanisms? So this is our problem. You're stacking sats on your secret wallet that you don't tell anyone about, and maybe you have relatives that you would like to inherit those Bitcoin to them one day. And then this guy comes along and your relatives can't get Bitcoin, it is locked forever. Another scenario is similar. You are keeping the sats on your wallet, and because you are afraid from theft, then you build some complicated way of storing it. For example, you use the passphrase, or maybe you split the seed of in many geolocations, and an accident happens, and you forgot the passphrase, and again, your relatives and you can't have your Bitcoin anymore. It is locked forever. And another case is that you think you are being more careful. You are stacking sats on your Bitcoin wallet, and now you have accumulated a significant amount. And just in case, you are making a copy of the seed, and you have one copy, and you give your relatives the other copy. And these other copies get stolen, and you lost the Bitcoin. So this is the dilemma of Bitcoin in self-storage. You can keep a simple solution, just a 12-word seed, and make lots of backups of it. And then it's easy to steal. Even if one copy is lost, the hacker can get, or the physical hacker can get access to your entire stash of Bitcoin. And if you make a complicated solution, you use a passphrase, you use a multisig, you use a Shamir, then it's very easy to lose it, especially if your relatives are not tech savvy and they don't know how to use this complicated solution, and they might go to experts who will try to explain them how to use the complicated solutions, but maybe some of those experts will be scammers themselves. So this is the dilemma for everyone in self-custody. Either you make a simple solution with lots of backups and then it can be stolen, or you make a complex solution and then it can be lost. By far, more Bitcoin was lost due to complex solutions, not to being stolen. Something like 10 or to 20% of all Bitcoin was probably lost due to people fearing from the Bitcoin getting stolen. So they make a complicated solution and then they, by accident, lost one of the keys or forgot one of the passphrases and lost access to their Bitcoin. So what if we could have both simple and complex keys, both a master key, that we can have it in a multi-sig or with a passphrase and memorize part of it and stuff like that, and also a secondary key that can access the same wallet, but with some restrictions. And the simple solution is a multi-sig. That's the most popular solution that everybody knows about. You have this one master key that can access the Bitcoin immediately at any point of time, alone, or maybe you have a 2 out of 3 multi-sig, and then you hold 2 keys, and a third-party service holds 1 key, and your relatives have the secondary key. And if you lost the master key or something happened to you and now they don't know the passphrase, then they can approach the third-party service, and together they can make a signature to move the Bitcoin out. Obviously, the third-party service will have put this relevant restrictions that you ask from them. They can verify the identity and verify that you are no longer with us if your relatives tries to extract the Bitcoin, things like that. And the advantages are that the Bitcoin, this wallet can be used for daily purposes. You can receive and send Bitcoin at any point of time, and you can create this kind of voting scenarios. For example, if it's a wallet of a company, then you can have board members voting to send the Bitcoin somewhere, and maybe some manager have some admin permissions to send the Bitcoin, stuff like that. The disadvantages is for simple users that they need to set up a multi-sig wallet. Most Bitcoiners just accumulated their Bitcoin on a simple Trezor device, don't have a ledger device. They never use multi-sig. It's kind of techy to use it. There is the issue of privacy. If you want to give the key to a third party, you need to give them details about you so they can verify the identity of your inheritors and or of you if you will want to use it in the future in the service. And there is an issue of trust. And those companies can be foreign companies, and maybe one day there will be regulation on them, and maybe they will give your credentials, and maybe just disappear, and there will be nobody to talk to when you need to recover your Bitcoin. Many of the companies, because of the trust and privacy issues, some companies I know, American companies simply don't serve outside America. So outside the United States, they say, okay, you're not American, I don't have the legal infrastructure to verify your identity, and we can't serve you as a customer. So how can you utilize time locks in Bitcoin? So let's recall what Bitcoin transactions look like. Each transaction has inputs, outputs, a version number, and a field called nlock time. So inputs in an array of inputs, outputs an array of outputs, and each input points to the output of a previous transaction, and it has the previous transaction ID, output index, an unlock script that kind of proves that I'm the owner of that UTXO, and a field called nSequence, and the output of how much Bitcoin and to which address I sent the Bitcoin. It's very different from Ethereum or from traditional bank accounts. You don't have a bank account. You just have a bunch of transactions and private keys that can access certain UTXO unspent transaction outputs. So let's go over the end lock time field. The end lock time field allows to create an absolute time lock. So you're saying, I think this one is, okay. I'm not sure this is the latest version of the Google Slides, but let's continue here and see if there are major differences. So this, in Bitcoin absolute time locks, there are the transaction. If the transaction is signed with a certain end lock time, then it means that it can be mined only after a certain block height or a certain date. So if the end lock time field is below 500 million, it's interpreted as a block height. And if it's above 500 million, it's interpreted as second since 1970 epoch time. It's not, the miners add to each block a timestamp. And sometimes the timestamp, the miners have a small incentive to not attach the real timestamp to the blocks, but an offset of the real timestamp. It's just edge cases for improving the mining process. So sometimes the timestamp of the block is not accurate. It can have like a few hours, 1 or 2 hours offset from the real timestamp that the block was mined. Sometimes you even see a block following a previous block where the timestamp has decreased. So this is a funny edge cases, but generally it's pretty accurate, and you can, if you don't care about accuracy of hours, you just want to have an end lock time for next year, you don't care about plus or minus a few hours. And the simplest recovery mechanism is just a pre-signed transaction with a lock time. So you have, you create an immutable transaction from the complex wallet to a simple wallet. There is no need to switch to a script supporting wallet. Any wallet can sign this. And even the Trezor, for example, doesn't support all kinds of script-based wallets. The disadvantages is that if you spend any of the UTXOs in your wallet, you basically invalidate the pre-signed transactions that point to those UTXO, even if you spent a tiny amount. You cannot add coins. So any coins that Bitcoin that you received after you pre-signed the transactions, then these coins won't be included in the pre-signed transactions that signed specific UTXOs. And there is a trade-off between when you are setting the deadline. So, for example, I can sign a transaction for January 1st, 2027. And then I have like this year, if I will lose my Bitcoin this year, I could use this pre-signed transaction, and if I lose the seed, I can use this pre-signed transaction and move the Bitcoin to a simple wallet. And now, if on December, I have to remind myself that I have this pre-signed transaction that I created multiple copies of, and this, once January 1st, 2027 arrives, this transaction could send the Bitcoin immediately. So if I want to keep this 1 year notice, 1 year ahead pre-signed transaction, I have to access my original wallet, which could be a seed split on different geolocations. And then I need to collect all the parts of the seed and move the Bitcoin to a new address, and only then the previous pre-signed transaction will be canceled. Different approach is to say, okay, I won't do it for next year. I will pre-sign transactions that could be used only 5 years from now. But then if I lose the seed today, then I don't have access to my Bitcoin for the next 5 years, which could be too much. So there is a trade-off here. Okay, I need to switch. I see that you don't need it, so I'll have to share the screen and do it normally. So this is it. How do I share my screen? Share screen. Share screen.
Maybe I'll remove it first. Try now to share your screen again. Okay.
Can you see my screen?
I'm still seeing black.
No, I haven't played the video yet, but
oh, now I can see something. Yes.
Okay.
Awesome.
I think my computer is a little bit slow.
Yeah, I'll remove myself at least from the stream. Maybe
it's really strange because it's Google Slides. I expected the integration to work smoothly directly with the StreamYard.
If you have it on YouTube or anything, we can just share the link here, at least so people can enjoy it later.
My Mac is struggling.
No worries. In the meantime, I can ask you some questions about it. As for do you think there are more use cases for this? I started thinking about it, and maybe you can also use it as not only for yourself, but maybe for public pools of money that you want to be transferred if certain conditions are met or something.
Yes, I think pre-signed transactions are can be very useful for simple users and are simply not talked about enough. Okay, I think I have to restart my Chrome. So just a minute.
Yeah, no worries. We'll wait for you for a minute. In the meantime, if any of you in the audience here would like to ask us anything about the community, about this meetup, or anything else, feel free to just ask us on the chat, on YouTube, or any of the other channels. And I will also encourage you to scan this QR, which leads to our link tree, which has all our different links to the community platforms, from the Telegram group, which is the main channel that we use, all the way to the Luma and Meetup links and everything else that we have, and also all the recordings that we had so far. So feel free to scan it in the meantime. Yeah, I see Oren is back with us. Awesome.
Let's choose this one, and let's hope you can see it.
Okay, it's loading.
Why
yes.
is it?
I can see the presentation.
Yeah, let's go to the where were we? Yeah, this one. And here you can see a demo where I paste a transaction on Trezor Suite, very simple. And I say I'll send all the funds from my passphrase wallet to the simple wallet. And I choose to add lock time. And I simply type the date. January 1st, 2027. I choose the fee. Now, I don't know what the fee will be a year from now, so I'll choose a high fee. And even if it won't be mined because the fee is not enough, I know I could do child pay for parent, or I could go to mempool space and just accelerate. And now that I'm signing the transaction.
Can you explain a bit more about that? I think it might be interesting as well. Like what can you do in this case that that the fee that you put is too low?
So if the fee is too low, right now it's not a problem in Bitcoin. The average fee is 1-2 Satoshi per byte. We have the problem that not enough people are actually using Bitcoin. But if the fee is not, in Bitcoin, there are only 4 megabytes of data that can be mined every 10 minutes on average. And if there are a lot of pending transactions, then the miners won't pick your transaction. Now, it's usually not a problem if you do have access to your seed. If you do have access to your seed, you can try to send the transaction, and if you see that it doesn't get mined because there are other transactions who are ready to pay higher fees than you, then you just bump the fee. You just broadcast a new transaction that pays a higher fee. But with pre-signed transactions that are meant for recovery, this is a problem because you are supposed to use it when you don't have access to your seed. So you can't just replace the transaction with a similar transaction that pays a higher fee. But you can do child pair for parent. So how child pair for parent works, you take some Bitcoin from a different wallet that you have, or maybe you already have it on the other destination wallet, and then you do child pair for parent. You send a new transaction that spends the UTXO of the previous transaction that you want to get mined, and this new transaction will pay a huge fee. And now the miners look at the pair of transactions and say, okay, the other transaction, I can mine it and earn its fees only if the parent transaction gets mined as well, because they are chained together. The new transaction will be valid only if the previous transaction is arrives to the blockchain. And if the fee is high enough, they would mine both transactions. They would say, okay, I will earn more fees from the child transaction than I will lose on the parent transaction, and then that's why it's called child pay for parent. Nowadays, you can go to a mempool space and just click at transactions and pick your credit card and pay them. It's a huge fee, usually like $100. So even if you didn't prepare yourself for this child pair for parent scenario, you can just pay them and they will pay the miners. And this breaks a little bit the incentive model of how Bitcoin is supposed to work, but they will pay the miners, and the miners say, okay, this transaction pays me a low fee, but I will mine in anyways because mempool space paid me. You can also pay mempool space with Lightning, so it's a different scenario. So what do you see on your Trezor device? And that's important because we are working with hardware wallets and we don't want to blind sign stuff. So you see the recipient address, and you see the amount, obviously. And you also see the absolute lock time. Trezor and most other wallets also show you this information. So you can see that this transaction cannot be broadcast today. We're still in 2026. And when we what we see on the Trezor Suite app is that the signed transaction, we can copy it as raw text, and we can save it as a file, and we can make lots of backups of it. Unlike the seed that you keep one backup of it, and with the passphrase, the signed transaction is immutable, so nobody else can just change the destinations or change the unlock time. It's cryptographically signed. And to broadcast it, you can go to mempool.space/tx/push, or to any other You can use your own node. You can. There are other websites as well. Blockstream has one. So, and then you paste the signed transaction and broadcast the transaction. The end sequence field. The end sequence field is more complicated than lock time because it has multiple purposes. It's a bit field with like each bit is a flag that says what's the purpose of this end sequence, and it can historically it was used to sign replaced by fee, whether this transaction can be replaced by fee or not supposed to be replaced by fee. Nowadays it's not a big issue because the miners. Even if you signal that you don't want this transaction to be replaced by fee, if the miners see somewhere a transaction that pays them a higher fee and spends the same UTXO, they will take it. There's no reason for them not to take it. So this, I don't want to go into these details of the history of replaced by fee. In the Bitcoin in transaction sum version 2, this bit field can be interpreted as a relative time lock. Relative to what? So each input has this end sequence field. And this end sequence field is unrelated to the unlocking script field. It's unrelated to where you put a public key and the signature of the transaction. So, and this field can be, if this flag is a time-based flag is set to 1, then this field will be interpreted as a relative time in the units of 512 seconds. And if this flag is off, it will be interpreted as blocks. And in Bitcoin, we also have opcodes. So we can use this in a combination with op check lock time verify and op check sequence verify. And these operators can be run on the locking script, and they can verify that the end lock time or the end sequence of the transaction is the same unit as expected and is at least some value. So you can have a script that says, okay, this Bitcoin with this key can be spent only in transactions that have an end lock time of at least 2027. So you can put conditions on the end lock time. And a question is, can we make transaction valid until a block height or until a date? So can we say, okay, this Bitcoin locked in this script can be spent only from June to November 2026, but not after November 2026? And the answer is no. In Bitcoin, there is a lot of part of the concepts of Bitcoin core of Bitcoin is to make things simple and simple enough for everyone with a Raspberry Pi at home to run a full node. So when a new Bitcoin transaction arrives to your node, and this transaction is has not been mined, it's still in the mempool, your computer takes these transactions and run the scripts to verify that it is valid. So first it validates that all the inputs are in the UTXO set, that they are real. And then it runs, checks the end sequence, checks the end lock time, that enough time has passed and this transaction can actually be mined. And then it runs the script of the Bitcoin. And this script contains all kinds of cryptographic verifications. It contains verifying that public key matches digital signature, and for computers in the cloud, this operation seems easy, but for a Raspberry Pi working on 4 megabytes, that's not so trivial to do this 4 megabyte of cryptographic verification. And for this reason, once you've verified that the script of a transaction is valid, in you will never need to verify this script again. You will only need to look on the inputs and see if some other transaction have spent them from the UTXO. So if you run a transaction and say, okay, now it is valid, and nobody else spends any of its inputs, then this, you know for sure that this transaction remains valid, and you don't need to run the cryptographic checks again. So that's why once you validate that the transaction is valid, it will always be valid, and unless another transaction spent the same inputs. So how can we use these opcodes? So this is a demo of Liana wallet, and I call it a delayed key wallet. And Liana, I think, is very useful for company scenarios and organizations that receive Bitcoin and send Bitcoin frequently, like several times a year. So you can have something like a majority vote, like board members of the company, and they will need to sign 3 out of 5 signatures to spend the coins. But what happens if 3 board members have a airplane accident, crash, the airplane crashes, and now you lost, 3 keys out of the 5. So you can also set to say, okay, 2 out of 5 signatures are enough to spend the coins if the coins received to an address of the wallet and weren't touched for a whole year. So after a whole year, 2 out of 5 signatures are enough. And the advantages are that you can frequently receive and send Bitcoin, unlike the pre-signed transaction. You can receive, and you know that every Bitcoin that you receive is covered by this mechanism. And the disadvantages is that, it requires a smartened wallet that most people have, and it requires to renew the Bitcoin if it was not often used. Well, it was not used often. So if the company doesn't touch the Bitcoin for a whole year, 2 out of 5 signatures are enough to spend it. And if you use it for yourself and you have this one master key that can access the Bitcoin immediately and one secondary key that can access the Bitcoin after a year, and you haven't touched the Bitcoin for a whole year, then the secondary key can use it. So if you're very active with your Bitcoin, that's a perfect solution. But for some people, they have this stash of Bitcoin that they are not touching for many years, and maybe they've split the key or memorized the passphrase or hidden some parts of the passphrase in all kinds of places. Pulling out this wallet every year to just do this small transaction just to renew the backup mechanism is kind of annoying. And the destination is not fixed. If you have this secondary key and the time has arrived, you can send the Bitcoin to any places you want. In some cases, maybe this is not desired. If you have inheritors that are not tech savvy, maybe you just want to have a pre-signed transaction that send the Bitcoin in case of emergency to a bank. And then they won't have, it will be custodial Bitcoin, but this is obviously only in the case of emergency. And the Bitcoin will arrive to an exchange under their account, and then there are less risk for the scammers to convince them to send the Bitcoin elsewhere. But obviously, with custodial solutions, the custodian can collapse on its own. So let's see how Liana script works. And this is, by the way, a real example. You can scan the QR code and see the transaction yourself. I tested it some time ago. So in the typical use case, the unlock script simply puts a signature of the master key, and then the script pushes the public key of the master key, and calls checksig. The signature is correct. The Boolean is duplicated, and we reach the end of the script successfully. This is what happens typically when you use the master key. Now, what happens when you try to use the recovery key, the secondary key? So the unlock script pushes these values to the stack, and then again the script runs, pushes the public key of the master key. This is obviously causes the checkstick to fail. There is nothing to duplicate, not if enters. And then there is a code that is very similar to whenever you do pay to public key hash. You duplicate the public key, you hash it, and then you push the expected hash of the public key. And once they are both equal, you check the signature and verify it. And you also check here the sequence. So you check the sequence of this transaction. So this transaction must be signed with n sequence that is at least 24 blocks. That's a very short time gap, but it was just a test. And we verify that the relative log time of the transaction is at least 24 blocks from the previous transaction. And now let's go to time lock recovery, BIP 128 that I wrote. And time lock recovery is a recovery mechanism that for Bitcoin that you are not planning to touch for a long time. So you have this wallet that you may have cut the seed into 2 parts and maybe added a passphrase and maybe hidden stuff in multiple jurisdictions. And there is a low chance that it will be stolen, but there is a high chance that because of an accident, you will lose access to it. So you pre-sign transactions to move the Bitcoin to a different, simpler wallet that you will choose just in case. And you pre-sign a sequence of 2 transactions that move the Bitcoin to a simple wallet with a cancellation window. And soon we will see how we're doing it. You back up and you monitor the pre-signed transactions. And if you lost access to the complex wallet, you broadcast the transaction, you wait the cancellation window time, for example, it can be 90 days, and you access the funds from the simple wallet. So how the pre-signed transactions look like. So you have here your addresses on the left side with your UTXOs. And you sign the initial transaction, also called in the BIP, it's called alert transaction. This transaction sends most of the funds back to your own wallet. So it's like a consolidation transaction. And it only sends 600 sats to a tiny amount to the recovery wallet. Why? It allows you to see that you're starting to receive things on the recovery wallet. Just verify let's verify that you have access to it. And B, it allows you to do exactly the child pay for parent that we talked about in the original, previously. So if this transaction doesn't get mined and you lost the seed for the wallet on the left, then you can use child pair for parent to get it mined by paying a higher fee in the child transaction. And you also pre-sign a recovery transaction, and this recovery transaction moves the rest of the funds after the consolidation to the second wallet. And this pre-signed transaction have a time lock of 90 days. So you broadcast the first one, you must wait 90 days, and only then you can broadcast the second transaction. And what happens if you made lots of backups of these pre-signed transactions? I recommend even making online backups of them. You can save it on a file, you can keep them online. Worst case, it gets leaked, and somebody broadcasts the first transaction. And then you get a push notification from the right-track service, or if you don't want, you can put yourself a reminder to check if the first transaction was broadcast every once in a month. You can do it manually, go to mempool space and check if the transaction became on-chain because it got leaked somehow. And then you have 90 days to respond. It doesn't have to be urgent. You have 90 days to say, okay, I don't want the Bitcoin to go to the simple recovery wallet. I will simply sign the transaction that move the Bitcoin from my address back to a new address. It can be even on the same wallet. So the advantages is that you have immutable transactions. You can pre-sign them. The hacker cannot change any of the details of this pre-signed transaction. It works on any wallet, on any hardware wallet. There is no to switch to a script supporting wallet. And there is nothing to renew here. If you have this long stash with a complicated passphrase and you split the seed somehow, you don't have to open the wallet every year just to pre-sign new transaction. You only have to do it if something got leaked. And the disadvantages, like the pre-signed transaction before, is that spending coins invalidates the pre-signed transaction. So it can't be a wallet that you add funds to on a daily basis. And you cannot find coins to the already signed transaction. So you cannot spend any time you spend from this wallet, you invalidate the whole pre-signed transactions. And every time you add new funds to this wallet, the new funds are not covered by the pre-signed transactions. And you need to monitor. So you can use the right-track app, or you can monitor it yourself by checking the blockchain manually or running some script on your node. So here is a quick demo. First we'll see how to use on our phone the Trezor suite. So here I have this small wallet with $17, a wallet without any passphrase. But if I will click this button and type passphrase and verify the passphrase on the hardware wallet, then I have access to my secret stash of 1 million Satoshis that nobody knows about because I did not tell the passphrase to anybody. And now I want to create a transaction from this secret wallet to the simple wallet. So I will go back to the simple wallet. I will click receive to create a new address. I will verify the address and even write it down to make sure, because I will need to type it again later. And then I will copy it. And I will go to the right-track app, choose the connect to Trezor. In Trezor, you have accounts. Electrum doesn't support it, but Ledger also supports it. It's different derivation paths. Each account has a different derivation path. In Trezor, they call the first account index the derivation path that ends with 0. I won't get here into what derivation paths are. It's how you create the private and public keys from your seed. And on Ledger, I noticed just an annoying thing that I noticed is that on Ledger, they start counting from 0, but on Trezor, they start counting from 1 here. Anyways, you connect your Trezor, it switches to the Trezor suite, you give the permissions, and you enter the passphrase, and you paste the destination wallet, so the simple wallet. And now you have to choose a fee rate. So to avoid complications, and because we are talking about recovering significant funds, and 99% chance that you won't even need to broadcast this transaction. This is just for emergency. We recommend just setting a huge fee. So 75 is a huge fee compared to what's in the Bitcoin today. Today the fees are like 1-2 Satoshis are enough to pass a transaction within an hour. But we recommend putting 75 Satoshi per byte fee, so it will you will be sure that it will be mined easily even 10 years from now. So you type a new, so for this example, I'll type a smaller fee, And I also chose a shorter destination cancellation window for only 2 days. And you sign the first transaction. So as you can see here the destination address, and you can see the amount of the first transaction. The amount of the second transaction is only 600 sats, so it's a tiny amount. And you confirm the transaction, and now you have to sign the second transaction. This is very similar. So you sign the second transaction. You see the same destination address. Now you see the larger amount, and you confirm the second transaction. By the way, if you didn't notice, what we didn't see here when we signed the transaction on the hardware wallet, I will leave it as a question to the end. And the RightTrack app uploads your transaction to the servers, and you have now a backup of it. And you can click it and see details. You can just add some remarks on some comments on the transactions, on the destination wallet, because in 10 years from now, you won't remember what is what, which transactions send which funds to which wallet. And you can also back up the files, the transactions. It's simply a JSON file. You can open it with Notepad, and you will see the hex of the two transactions inside it. And you can send it online to your family and friends. Dear family and friends, my Bitcoin wallet seed phrase and Trezor are hidden at some special location. But if you open that wallet, you will see almost empty, because this is the simple wallet. Because I also use the passphrase or some other wallet scheme to hide my Bitcoin. And to move the Bitcoin, you take this file and go to righttrack.com/send and just upload the attached file. And this is how righttrack.com/send looks like. It's a website where you can upload the file, review it, and then initiate the transactions with a button. It will broadcast the first transaction right away, and then wait the amount of time block days. Here we can see it's 2 days, and then broadcast the second transaction. And obviously, you can also initiate the transactions immediately from inside the app. Initiate, and you will see the progress bar here. It has 5 steps: the initial transaction broadcast, confirmation, the second transaction broadcast, confirmation, and finally 6 confirmations, which is more than enough to be sure that the Bitcoin has arrived to the destinations. And anytime the Bitcoin moves from those the inputs of the pre-signed transactions, then you get a push notification. So you get a new message that the recovery plan has been initiated. Now, here we can see that the progress. We still have 2 days to cancel things, and to cancel the transactions, if something has been leaked or your family just decided to upload the JSON file without your permission for some reason, or somebody hacked their email and tried to do it for some reason, then you have 2 days to respond, and you simply go to your, you see that 600 sats were sent from your wallet. That's because of the first, the broadcast of the first transaction. And you can just click a receive address, copy the address, and then click the send button and send the Bitcoin to yourself. So once you send the Bitcoin to yourself, you invalidate the recovery transactions, and you choose any fee that you want, and you confirm the transaction. And now you will see on your Trezor suite a transaction with this back arrow on the top, because it tells you, okay, you are sending now Bitcoin to yourself. It seems silly. Why would you want to send Bitcoin to yourself? But the purpose in this case is to invalidate the second transaction that could be broadcast in the future. Obviously, you get a push notification. Whenever something happens, you get a push notification. You can also set an email, and you also get an email. And the message is that the recovery plan was canceled externally because we noticed that you took your wallet and you moved the Bitcoin to a new place. If you have other wallets than a Trezor or Ledger, so I also wrote an open source plugin for Electrum, and you can. It's now officially in the latest versions of Electrum. You enable the time lock recovery plugin, and it looks like this. You paste here the destination address. You can also paste multiple destination addresses. So you can say, okay, half of my Bitcoin will go to this address, and 20% to that address, and 30% to a third address. And you can view the details of the transactions. Here we can see the first transactions. It sends most of the Bitcoin from a green address, which means it's an address on the wallet, back to itself, but it also sends 600 sats to the secondary wallet, to the destination. Okay, and you then sign the second transaction, which sends all the funds to the destination address. And you can then save the details as a JSON file, and then you can upload it to the RightTrack app. Or you can save everything as a PDF, and it's a very nice PDF. And making this PDF was harder than making most of the logic of the plugin. And this PDF gives you a full detailed explanation how to broadcast the transaction. It's really explanation for dummies. You take this QR code, you scan it, you copy the content, you go to mempool space TX push, you paste it there, you wait 90 days, etc. And here you can add the JSON file. Now, if you want to add funds to your Bitcoin wallet, the one with the passphrase, I recommend using accounts. So this is a feature that not all wallets support, but Trezor supports. Ledger also supports. And you can add another asset of Bitcoin. And it must be a SegWit. And once you added it, you will see that you have 2 Bitcoin assets on your wallet, and the difference between them is the derivation path. So the first wallet, the first account is a derivation path that ends with 0, and the second is a derivation path that ends with 1, and this is what you saw on the accounts before in the demo. And you can just change some details. These details are not saved on chain. They are only saved on the Trezor suite. So if you remove your Trezor suite and reinstall it, it might disappear, but it's a good to put a reminder on the first wallet. Don't add more funds to this wallet, because if you will add more funds, it will not be covered by the recovery mechanism. And then you have these 2 wallets, and when you want to add funds to this wallet, you have this reminder, okay, I need to add funds to the second account. And once you accumulated enough Bitcoin on the second account, you can create another pair of pre-sent transactions, and either a time lock recovery plan, and upload it as well. That's it. That was the demo. You're welcome to visit the website, check it yourself, and for technical information, go to timelockrecovery.com and read the BIP.
Amazing. Thank you so much, Oren. So just before we dive into all the questions that we prepared for you as well, and give some time to the audience to ask some questions, I have an awesome surprise for everybody who sticked around until now. Just a sec. Okay, so if you guys will scan the QR code at the top of the screen, you will get a chance to win Paris Blockchain Week tickets from us. We have a lot of tickets to give to the community, and we would love to see you there. So,
am I allowed to participate as well?
You're not only allowed, you're encouraged to participate. There is a short form that you need to submit and show that you're a part of the community. And any one of you that is in our Telegram group will be able to win tickets to Paris Blockchain Week. I would add that the tickets are pretty expensive, so we would love it if all of you will use them and come, and we would love to see you there. And now back to the questions. So first of all, you said that there is one thing that you're keeping for us for the end. So I would love to start from there, and also I would love to add Ariel from our team to also ask some questions as well later.
So it's more of a question for you. I've pre-signed 2 transactions. And I've pre-signed a second transaction, and I showed on the hardware wallet the amount that I'm sending, the destination address that I'm sending, the amount of fee that is being spent on the second transaction. But there is one important details on the second transaction that was not displayed on the hardware wallet. Who can know the answer?
Ariel,
from the audience, I don't see. If you followed.
Can you rephrase it?
So the recovery mechanism is based on 2 transactions. One is a consolidation transaction, and the second is a transaction that is supposed to be broadcast only 90 days after the first one with a special end sequence field. And when I signed the second transaction, I saw on my hardware wallet, when you're signing a transaction, the entire purpose of hardware wallet is that you don't trust your computer, you only trust what you see on the hardware wallet. So on my hardware wallet, I saw that I'm sending a specific amount, and I'm sending it to a specific destination, and I'm sending it to with a special specific fee. Is that all the information that I want to verify on my hardware wallet?
On the second wallet? On the second wallet, you mean?
No, on the same hardware wallet, some information was not displayed. Maybe someone from the audience wrote something. No?
Yeah.
I can see what's the writing.
Let's see. First of all, audience, feel free to jump in and say something in the comments, and maybe save me and Ariel.
So, the missing part is the end sequence field. So I wanted to sign a second transaction that can be broadcast only 90 days after the first one. But what if my computer is compromised and it's signing a second transaction that can be broadcast only 2 days after the first one, or only half an hour after the first one, or only 0 minutes after the first one? So this is something that I'm nagging Trezor and Ledger. They for some reason they've skipped these important details that it's important. When you use an end-lock time, you see the 2027 January 1st. But when you sign transactions with the relative lock time, you simply don't see it on the hardware wallet screen. I don't know why. I also wrote some add-on, some pull requests to Spectre wallet. So now Spectre wallets do show this information, but it's kind of a niche project. It's not very. Trezor and Ledger are far more popular, and I expect them to, show me this detail, especially if it's a custom end sequence and not the trivial one. Any questions?
So currently, just to understand everything, so currently there is no hardware wallet that can display this end sequence?
So in the next version of Spectre wallet, it will be displayed. It's not a big issue as I'm talking about it, because you do see that the most important details that you want to see when you are signing transactions is the destination address. because you are moving the Bitcoin to a destination that you know, and not to a scammer. So this is information you do see. You see that you are signing a transaction, that you move your Bitcoin from your main wallet to your second wallet, or to a custodian that you trust, or to a friend that you trust a lot. And it's important that you also see the fee, that you are not spending too much on fees for some reason.
Okay, thank you. And now actually I have, first of all, just say if I have any issue with this protocol and this project, most likely I will send you an email or text.
Of course, yeah.
This is, I think, the first solution that I would think come in my mind. So yeah, that's great. And actually I have a couple of questions for you. A little bit, so I will start and let's see how it goes. So actually, with the potential future of soft forks and upgrades to the Bitcoin script, can users be confident that the pre-signed recovery plan that's created today will still be valid and accepted, in the network for like a decade or something?
So yes, the Bitcoin is very care a lot about backward compatibility. So if you're signing a transaction today, the ecosystem will have a lot of pressure to keep supporting what you are signing, that your transaction will still be valid. Saying that, quantum computers do pose some risk to that, and maybe things will change if we see that quantum computers suddenly have access to millions of Bitcoin or something like that, and can Bitcoin that was thought to be lost forever, or that the owner, and maybe things will change in the protocol, but we are not there yet, and you do need some recovery solutions now. So yeah, I think for the next 5-10 years, we won't have so quickly quantum computers that can take signatures and reverse the private key, or mutate the immutable transactions. But yeah, we'll have to follow it.
Yeah, follow and see the future.
And building on that, by the way, if Bitcoin will have an update that will change the hashing to a quantum proof algorithm in the future, will that also affect the time recoveries?
I don't see. You will have to move your Bitcoin from an old wallet to a new wallet, from an old wallet that is not quantum safe to a new wallet that is quantum safe. And if you do that, then you invalidate your recovery, your pre-signed transaction anyways. So there is no reason that if we will move from the current signatures to quantum proof signatures, anything about time locks will change.
Awesome. I have a few questions from the audience that was sent privately, so let's present some of them. I think it's a bit too long for this. So does BIP 32 derivation path logic ever result in an accidental generation of a public key or address that has already been used? Specifically, how does the protocol ensures that every newly derived child key is unique and hasn't been previously utilized within the same wallet or by another user? So it was a bit long.
So this is a question about BIP 32. It's not a question for me, but math.
132 maybe.
Huh?
No, sorry. Maybe it's a mistake. But yeah, anyways, if you know how to answer it, it would be great.
So from what I know, it's a very it's used in many wallets, and yes, every time you derive from your private key you use a derivation path, a different derivation path, you will get different public keys and different private public keys pair. We got the alert here. So,
Of course.
It means we have only 2 minutes before you have to go.
the missile alert, yeah. So every time you have you use a different derivation path, you get a new key. It's an old cryptography. It's really not up to the time lock recovery things to verify. It just happens that if that's what all the accounts and the fact that you can use a seed to derive many private keys and many public keys without repetition is based on that, because in old wallet you simply saved a bunch of private keys in a file and had to backup it. So I'm not into the elliptic curve cryptography that can explain it.
Just to let the audience know, so maybe Oren is gonna get an alarm and will need to leave quickly.
Yeah. No, it's okay. I have reception for my shelter here. I can take the laptop with me.
That's a bold move. That's impressive. So we'll continue with the questions, but anyways, you need to get like a bonus for doing this under fire. Anyways, so
it's much more noise that wake you in the night than a fire. Actually, fire, but okay.
Awesome. So I wanted to ask if this is gonna work on Lightning as well, because Lightning, if I remember correctly, is using time locks. So the implementation is very similar to Lightning. In Lightning, you also have this mechanism where you have keys with time locks that you can access if the other side is not responding. And if the other side doesn't collaborate with you about closing a channel, then you can use these transactions. And after 24 hours, you will get your money back on chain. Why is there a delay? Because if you are trying to use it and try to cheat and try to withdraw more funds that you deserve, there is a very smart mechanism that if you will do it, you will get your Bitcoin after 24 hours, but within these 24 hours, so the other side could get the Bitcoin immediately because you broadcast some information that allows the other side to withdraw the funds immediately. So that's why time locks are used in Lightning. But Lightning wallets are inherently hot wallets. You have to be online, or you have to have some server for you online that will notice that the Bitcoin, that the other side of the Lightning is trying to cheat you, and then we will use the keys to sign transactions that invalidate the other side's cheating attempt. And therefore, Lightning is always hot wallet. And we're talking about funds that you want to save, significant amounts of funds that you want to save for 5-10 years from now, not on hot wallet amounts. So I don't see a reason to create this kind of backup mechanism for private users who use Lightning. Maybe organizations, companies that use Lightning with large amounts, they will need more backup and recovery mechanisms, but that's off scope for this BIP. Just out of curiosity, in the near future, do you see this getting used in like more semi-traditional places as well, or even like exchanges, or will it be useful for as an infrastructure maybe in the future for any account?
So I think pre-signed transactions are already used. I've seen some services as infrastructure for businesses. It's the simplest thing that you can have. And if you notice something too fishy happening in your wallet, you have these pre-signed transactions with a fixed destination and a fixed UTXO that it's spending, and you can immediately broadcast it without having to sign things and and it can move to the Bitcoin to an ultra secure wallet. So it can be used. You can also chain more transactions than only two. So in this example, in the private personal use case, you only need 2 transactions to say, okay, if I lose access to the mate's wallet, I have a pre-signed transaction that within 90 days will move the Bitcoin to a second wallet. But you can also say, okay, now what if I have lost access to the second wallet? Then I can also pre-sign transactions that will send the Bitcoin after 30 more days to a third wallet. And I can have a backup mechanism that will send my Bitcoin to my brother. And if me and my brother knock, died in a car accident at the same time, then after 100 days, the Bitcoin will move to my cousin and stuff like that. So pre-signed transactions are very useful when you talk about saving for a long time, and you can do a lot of smart things with that without having to deal with scripts and different scripts and complicated multisigs.
Awesome. Ariel, you wanted to ask another question?
Yeah, of course. I have a lot more, but I will make it short. So actually, it sounds like I really like the presentation and everything, but do you plan maybe to support coins other than Bitcoin with this technology?
So this technology can easily support coins that are similar to Bitcoin and have a similar end sequence field. Other popular coins like Ethereum don't have it. So in Ethereum, you can do similar things and even better things with smart contracts. You can even create this recovery mechanism for a wallet and still DCA into that wallet, and you know that the new funds. But if you have a simple wallet, you will need to move the Ethereum from the simple wallet to a smart contract wallet. And this is something that even, I'm addressing this app for simple users, less technical users that just have this Bitcoin stash and they don't want to touch it for many years, and maybe they are playing with a hot wallet on their phone in Polymarket, but their significant amount of funds won't be touched for the next 5-10 years. So there is that, and they don't want to give them complicated solutions that will require them to move their Bitcoin or Ethereum to a new type of wallet that they don't know how to use. Yeah. But I'm sure that when it comes to stable coins, yes, I think that keeping dollars for 5 years is not good financial advice. You are losing to inflation. You don't get interest rate on them. But many people want to do it. They want to take a significant amount of funds of stable coins and not touch them for the next 5 years, and they'll have it stable coins for emergency use case. So I see the need from simple users to have good recovery mechanism for stable coins.
Just a thought, maybe I'm saying it is wrong, but it might be also useful, like the pre-signed transaction might also be useful to like bigger organizations that wants to show that they have enough funds somewhere, but in case anything gets compromised in any way, it's a good way to get the funds out to another disclosed location that everybody agrees that is the next place or anything like that. It's also a possible use case.
Yeah, and they are doing it. These mechanisms already exist in some solutions. I don't remember the name, but there are services that are more B2B businesses, and they go to exchanges and banks and stuff like that, and tell them, okay, we will make sure that you have pre-signed transaction. The downside is that every time if they touch their Bitcoin a lot, that they have to create pre-signed transactions every time they spend any amount. So it's depends how active they are with Bitcoin or crypto stash.
Can it also be used as like a promise that they will not touch it? Because if they will touch it, you can see the pre-signed transactions cancel. So
yeah, but you can you don't have to pre-sign transaction. Once you know their addresses, you know when they are moving Bitcoin outside these addresses. So
yeah, okay, yeah, it makes sense. I wanted also to ask, but I think you already somehow answered that. But like, what do you do if I created a transaction and right after that got Bitcoin to the same wallet, or something like that? I need a new transaction, but is there a way to get over that, or like to prevent someone from sending me someone unknown, let's say, from sending me funds to the wallet?
If someone unknown sends you more Bitcoin, then this Bitcoin won't be covered by the existing pre-signed transaction. I don't know, it never happened to me that somebody sent me a significant amount. There are dust attacks, but not significant amounts that you really care about.
More like sending you 100 Satoshis, for example, just to settle with your...
You won't have a recovery mechanism for these 100 Satoshis. Okay, it's not a big deal. Those 1,000 Satoshis won't be covered. The more problem is, what if you withdrew from some Bitcoin from an exchange and you accidentally withdrew it to the same wallet that you already created a backup mechanism. So technically, you could create a pre-signed transaction only for the new UTXO that was created. But I don't recommend doing that. I recommend invalidate the entire pre-signed transactions and create them from scratch, because if you keep multiple pre-signed transactions on the same wallet, then you can have accidents. You can send an old pre-signed transaction that will cover only some UTXO, and the new pre-signed transaction that cover all the UTXO becomes invalid because you spent some of its UTXOs. That's why if you do that, I recommend separating accounts is very useful, because Bitcoin is pseudonymous. It's not anonymous. So it's very useful to, if you buy Bitcoin from multiple exchanges, you can withdraw each Bitcoin to a different account. And now okay, this is from Binance and this is from Kraken. And if you want to sell the Bitcoin, and for example, Binance doesn't work well with Israeli banks, you can say, okay, I will sell to Kraken the Bitcoin that I bought from Kraken. And then you can be assured that the Bitcoin will be accepted by Kraken, and the money you can withdraw the money, the fiat money, back into your local bank.
Okay, awesome. Ariel, you had a few more questions, and then I have the finishing questions for
finishing one. Oh my god. Okay, so actually so my question mostly is like, it's specifically about the product. So what is the practical risk of someone stealing the backup recovery code? For example, like, does the time lock provide enough of a buffer for the original owner to react?
So what exactly do they steal? If they hack someone's phone?
They steal, for example, you show us a demo that you send the backup code through email, and for some reason someone got into this.
Okay. So first, there is some issue for privacy-related issue, because if you see the transactions, you see the person's UTXOs and you see the person's addresses. So yeah, Bitcoin, using Bitcoin very privately is hard. I don't, if you want to protect your privacy 100%, and you are really worried about this issue, then you can use Electrum to pre-sign transaction and connect the Electrum to your own node, and then you can never upload the pre-signed transactions to any online service, including not to RightTrack. And then you have to create some monitoring mechanism. Back up the pre-signed transactions, print them on a paper, or keep it on a USB stick, and somehow monitor the transaction IDs and see if they get mined by accident, if somebody hacked one of your physical copies. That's Bitcoin, and privacy is it's a difficult topic to talk about. The app itself doesn't require you to put any credentials. So unless I somehow collaborate with Google, I will not know who you are. Even if you use the pay service, I don't get the money from your personal credit card. I get it from Google Play Store. So I'm not trying to track your credentials, but yes, the pre-signed transactions contain information about the addresses that you have, and we can see that this list of addresses belong to the same user.
Okay, thank you.
You have any last question, Ariel?
Of course I do.
Awesome.
Okay, so I come across I want to say it properly. So can you elaborate a little bit more about covenants and how can they create a better recovery solution?
So there are some suggestions to Bitcoin with op check template verify and op vault. Right now, when a transaction lock script and unlock script is run on the inputs, it verifies signatures. It verifies the whole that the whole transaction is signed, but the script itself doesn't care where you spend the Bitcoin to. You can spend it anywhere you want. So if you have the private keys, and if you using a script that can check the lock time and enough time has passed, or the end sequence and enough time has passed, that you can use the private keys to send the Bitcoin anywhere you want. And the covenants are the idea that to create keys that you can use only to spend to specific outputs. For example, it can be a list of addresses, and then you will have you can give your family a private key that they can use to sign transactions from your wallet, only goes to a specific bank. So they can't just sign any transactions that you want, and you can accumulate more funds. The problem that you have with pre-signed transactions, that you can't accumulate more funds. But with this kind of wallet, you will be able to add more funds to the wallet, and the most funds to the wallet will be included under the secondary private keys that your family might have, but they can't use the private key to send the Bitcoin anywhere. They have to send it only to a specific address. And it can be a recursive thing. So you can have the second address is an address that must be also the script that spends from this address also have to follow some covenant rules. And there are lots of debates in the Bitcoin community about covenants. One of the worries is that it will allow you to create some kinds of sub-token in Bitcoin. So if you think about it, if you create a covenant, a recursive covenant that says, okay, anyone who wants to spend the Bitcoin can spend the Bitcoin only to an address that follow the same covenant rules, and only if it has an op return that says hello world. Now you created some Bitcoin that the Bitcoin network verifies that it can only be spent with transactions that have op returned hello world. And it can never be spent to a wallet that doesn't do it. So you created a sub-token in Bitcoin that is not truly Bitcoin. It's not, you can't use it for any purpose that you want. It's becoming more dangerous if governments start to intervene and create some covenants that can be spent only to a whitelist of addresses. So I don't think full covenants will come into Bitcoin soon, but maybe in the future. And if they do, it will enable to create a smarter recovery mechanism where you create this recovery mechanism that your family and friends can access the Bitcoin within 90 days. And even if you add Bitcoin to the same wallet with a DCA or something like that, then the new Bitcoin, the new UTXO, will automatically be covered by the private key that you give to your family and friends.
Awesome. By the way, just another question that I thought of now is, like, are there solutions that are similar to that in Web2 today? Like, is it something that's new in Web3 that we weren't able to do before without a third party, let's say, to do it for us?
So I recently was asked by Google if I want to give someone else in my family access to my Google account if I am not active within a year. So they have this dead man switch service that you can set, okay, give access to my family to my entire Google account if I don't open the Google account within a year. And when you think about it, it is more similar to the delayed key, the Liana wallet solution, that if you don't touch the Bitcoin for a whole year, then the secondary key can access it. So yeah, it is a similar idea.
But like for now, banks doing it manually and taking a lot of money for that. Like, this is what's happening today. In case, let's say, I have funds in a bank account.
Yeah, that's an issue. You know, when people pass away, transferring their savings to their according to their will to their children is not an automatic service, and it can take a lot of time. I know for my personal, my father is an only child, and they thought that the will be trivial because he doesn't have brothers or sisters to share the inheritance wills. And my grandmother wrote a simple will. She inherits all her money to her son, and she didn't write that she's inheriting all the money to her only son. She just said to my son. And then, the court said, "Hey, wait a minute. Are you the only son? How do we know that you are the only son? Maybe she has some other children that she never reported on." And it took actually some time to get the money. So yeah, with pre-signed transactions, you can set a time lock, and within 90 days, the Bitcoin will move to whoever you decided. And no one can stop it, not banks, not governments.
Will it also be possible to transfer like tokenized bonds or stocks or anything else like that?
Sure, yeah. Pre-signed transactions can theoretically be a mechanism to inherit everything.
Amazing.
On any chain.
Okay, so I think we can start with like the final questions that we have, more about you and less technical. So I would like to start with like your background and story. How did you start in the ecosystem? What did you do before joining Web3? How did you get into this space? If you can tell us a little bit.
So I'm very late into Bitcoin. I think everybody after 2010 thinks that they are late into Bitcoin, but I'm very late into Bitcoin. I bought some in the 2017 hype. but then really got it in the COVID. And I got it from the most maximalist way, that, it's not about something that I want to use and somebody is not allowing me to use my normal money to use it, but it's money for emergency situations. It's like digital gold. It's something that you keep away from the government because the government in times of emergency can act in crazy ways. So we saw it during COVID. I'm not anti-vaccine, but I do think that many governments, acted like clowns, shutting down the entire country or opening some of it, and the ministers themselves don't follow the orders that they are giving to the rest of the people. So yeah, that's my story. I got mad about how I don't know if my bank savings will remain in the bank because the legal system invents itself every new week. That's in COVID. And I developed a few open source stuff that you can look at, niot.space with some few projects of mine, ln2.email, and some apps for Umbrel, like a Woofbot. Woofbot is like if you're running your own node, and too few people do it, but you should. And then you can use Woofbot to monitor the blockchain and send you Telegram notifications. It was for OpenClaw many years before, so you can tell your Telegram bot. That's a website. You can tell your Telegram bot if this address receives funds or some funds leave this address, or somebody opens a Lightning channel to your node, or somebody closes a Lightning channel to your node. Send me a push notification on Telegram. So it's useful because people don't check, their node all the time. They sometimes want to know things. So I worked on an open source project, and I've been to the Mamram blockchain competition, and with some friends, we won the competition over this idea of the time lock recovery mechanism. And we built it. We tried in the last year to have collaborations with exchanges, so it will be more a smooth experience. So you can create pre-signed transactions that move the Bitcoin to an exchange or to a lawyer, and you won't have to manually type the address of the second wallet that you have, because it will be an exchange or a bank or a lawyer, and it will be a smooth integration. But unfortunately, we have been running with this. We didn't find a major collaboration. So right now I'm releasing the app as is, where you do have to manually type the second wallet, and maybe if you will see that there enough, it will get enough traction, and you will see that enough people care about saving their self-custody Bitcoin and creating recovery mechanisms for this, then maybe we will have collaborations with exchanges in the future.
Awesome. The next question I have is, what's your favorite thing about what you do today, specifically in the space? You can also add something else if you would like, but
So I think Claude and the AI tools allow you to do amazing things. I have this idea recently, and I also published it on the niot.space, to have this explorer for the Bitcoin transactions. So right now, the block explorer, like mempool.space, you can click a transaction and see details, but you cannot visualize how it's connected to other transactions. I saw in one of the slides that a transaction is like a node in a graph that has edges to other nodes connected, and it's actually a flow of connected nodes. And this is something that is pretty hard to implement if you code it yourself. And then with Claude, I just wrote this huge markdown spec and told it I want to visual transactions, I want to have add transactions and click the output of the transaction and automatically show the other transaction and so the connection between them. And just like within 2 days, I built this, explorer that I once dreamed I would have, and I thought that building it would take me a month or two, and I did it in 2 days, weekends. That's the way Claude, especially when it comes to front end, it's kind of scary because my past jobs were in doing a lot of front end stuff, and now this front end knowledge, Tailwind CSS. Nobody needs people who know Tailwind CSS. You just tell Claude, visualize it nicely and add some padding and margins to stuff, and it makes this button blue, and it just do it. So this is amazing that it can help you. Anybody who understand the logics behind stuff can build beautiful UIs to visualize it.
By the way, like building on top of what you just said, like what would you recommend people to like learn more and get better at, so that they can use like all the AIs that are getting better every day, better specifically in this space? Like where do you need to focus?
I don't know. I don't know. You have to, it's a psychological, it's an identity crisis, seeing that, a robot can do things that would take you months with a day and intelligent things. I think the Claude Code is very good in front end, and it's very good with things that have previous examples that some other people did something similar in the past, because it, as I said in the previous talk, there are no more copyrights. He just scanned the entire internet and he will give you similar examples, and he doesn't care if they were copyrighted or not. So this thing. So if you want to have an edge, you want to keep having an advantage of doing something that AI can do, is to go into the details of protocols and into low-level stuff and into, I guess, new things that don't have code examples for, new algorithms, and learn the terminology. Because if you just tell the Claude Code, do me a nice website, he will do whatever he thinks best at the moment. But if you want, to the specific technology, and you want, okay, I want to build a website with WebSockets and 3D with this specific 3D visualization, and I want to build it with React and not Angular, and I want to build it with React Flow. So if you know the names of the packages that you want to use, the names of the technologies that you want to know, it's very important if you want to build a good product.
Awesome. And that resonates with a lot of other advice that I got about this topic. Amazing. Okay, what are you excited about in the space? What are you waiting for? Aside from a Claude update.
I'm excited about adoption. The bottom line, you can have a really good smart invention that people don't want to use, and just because they're lazy to learn it. And you see, for example, the gold price have risen in the last 2 years. It's silly. The people reason buy gold is because they haven't heard of Bitcoin. They haven't thought about it enough. That they aren't really using, but that's what they know. They know that if they fear from inflation, then they should buy gold. That's what their parents and their grandparents and grandparents have done. But once you see real Bitcoin adoption, especially in the spaces that you think Bitcoin is most needed, then that's something that excites me. Going to, in Israel, you can invest in real estate or invest in the S&P, and you can avoid inflation. And you probably don't get sanctions by the bank that quickly if you do the simple stuff to avoid inflation. But if you see people in developing countries, in much more corrupt countries, it's not their fault that the government is corrupt. Or I've recently came back from Taiwan, a country that is where the people are seriously afraid that one day China will take over. So if you see adoption of Bitcoin in those community, it's amazing, because that's what Bitcoin is all about: having cryptographic keys that the government can't take from you, and it's not losing value to inflation. And the political aspect of this is amazing. It connects people between borders, between nations, between languages and religions, and everyone around the world.
Amazing. Okay, two last questions. If you have any mistakes that you're familiar with that you recommend builders in the space to avoid, any anything that you think is good that we remember to not do also?
So most important thing is check your assumptions about the market before you go to, if you're just implementing some open source stuff for fun, do what you want, But if you want to build a business, you need to check the market before, check your assumptions about the market. So we were sure that, for example, lawyers will want our solutions. Lawyers will have customers who want to have pre-signed transactions that in case of emergency, they will execute them like executing a will. And customers will pay on a monthly basis, a kind of insurance service to the lawyers. And all the lawyers will have to do is to help them a little with a pre-signed transaction, with an app or with a dashboard, and keep the pre-signed transactions safe in their locker. And lawyers don't want to do it. All the lawyers that we've talked to said, no, I don't want this responsibility. I want to customer to come to me. I will sign the paperwork that he wants me to sign. I will help him make the paperwork, and they will sign it. And I don't want to promise the customer to keep this paperwork for a long time. I want to promise them that it won't be exposed to anyone for a long time. And I will send him to the official government, I forget the name, where you put the will, and they will keep the will over there. So yeah, the lawyers, even though we said that customers will pay for it, they don't want any responsibility, and they prefer doing the old business of just helping people with filling paperwork. So sometimes adding more, saying to someone your customers will pay for it, is not enough of an incentive to convince someone to start a new business, a new type of business. So yeah, as builders, we sometimes have this hammer, and we think every problem is a nail that you just need to use it on. And sometimes that's not the case. You have something that is very useful, but you need to know who will pay for it and who is willing to change his business and his thought process in order to use it.
That's an awesome entrepreneurial advice. I can agree from the VC side at least. And one last question. I would like you to give us one tip for builders and developers in the space. It can be anything from like things that you do in your private life that helps you to an entrepreneurial tip as a technical builder that you've learned along the way. You can also give more than one tip if you have a lot to say, but at least one tip.
An advice: do open source. Yeah. You see, you hear about the guy that wrote OpenClaw, and OpenClaw, which was a huge success, and everybody installed it, everybody love it. It was his project number 46 or something. So the guy did like 40 projects that were total flops and failed, and nobody cared about them, and nobody used them, and nobody noticed them. And he just kept doing more and more projects until something hit. So people think it's like magic sometimes, but someone comes up with a genius idea, but it's just after many ideas that failed. So yeah, that's my entrepreneurial advice. And the open source world, if you do something that is completely free, some nerds on the internet will try it and will give you some, talk to you about it and give you some advice, and maybe you can learn from it. And maybe it will be useful to someone. Sometimes you don't need to do everything for profit.
Where do you put like open source stuff, by the way, usually?
So I have some project on NIoT.space. Sometimes it's not a whole project. You just go check a nice project that you like on GitHub. It can be as simple as if you're not a native English speaker, just find a project, and you don't have to be a coder. Find a project and translate it to your own language, and that can be translated tip cards, for example. You can put some print notes and give people small QR codes that they can scan and get with their Lightning wallets, and people can hand it anywhere they want as tips. There are small projects that look for people to contribute, and Bitcoin will succeed when it takes over, because because it's a counter reaction to inflation, but also because it will simply be very easy to use. And if it will be very easy to use for small amounts quickly, then I believe people will use it. Why not?
Amazing. So I would like to thank you for this amazing talk. So thank you so much for the fascinating lecture and all the questions that you've answered. It was awesome. Before we finish, I will encourage all of you again to scan the QR code above so we can see you at Paris Blockchain Week. And just a sec. I'll put this here. Oh yeah, that QR is already the right one. Awesome. So thank you so much, Oren. It was a pleasure. And for everybody that joined us today, I would like to thank you for joining us. And if you like our content and you would like us to continue doing so and would like to support us, please join our Telegram and share with your friends and everything that you think that might like our technical content. We would love to have all of you. We're an open source community, and we would like your support in any way you can. If you're interested in technical entrepreneurship, if you like Web3 technologies, we're here to help. And we want you guys to learn from the best. We like connecting, and we like helping with hiring as well. And we would love your support and feedback along the way. So if you want to take an active part in the community or speak at one of our next events, please let us know and reach out through the Telegram or website. Also, every one of the team members at Web3 Devs Underground is available for your messages. We're available mostly on Telegram. And for those listening for the first time, we are the Web3 Devs Underground. We're all about top technical content, open source, and no shilling content. So, and of course, this is all done by builders for builders. So thank you again, Oren. And everything we do is, a disclaimer, is always free, reliable, and is for the community. So we encourage you to follow and subscribe to all our platform, and join and subscribe to the event calendar on Luma. There you can see all our future events as well. And see you at the next one. Awesome. Thank you so much. Bye-bye for now. We'll share all the links later below, by the way. And just a sec. Oh, yes. And I would like to congratulate in this chance Ariel for joining our team. Thank you so much for joining us, Ariel. It's great to have you.
Thank you. Great to be here.
Awesome. And I'll put here as well the link to the Paris Blockchain Week. Yeah, there you can see it as well. If you're having any trouble scanning the QR code, this is the link to the questionnaire. Fill it out, join the community, and you will be able to win tickets to Paris Blockchain Week. I think every ticket is about 1,400 euros per ticket. So we bought a lot of tickets for you guys, and we would love to see you there. This is encouraging to support the community and help more builders reach this amazing conference. And I think that's it for now. So see you all next time. We're available through the website and links. I'll put here our link tree that will also show you how to join the community and learn more about us. This is the QR for the for our link tree. You will be able to see all the past recordings that we've had until now. There are a lot of amazing content there, and we're encourage you to dive in. So thank you so much for joining us again, and see you on the next time. Bye-bye for now.